Good morning, one and all present over here. I request Dr. Bhagyalakshmi Jaina to take the charge and carry forward today's session. Bhagyalakshmi Madam.
Thank you, Dr. Somyaranjan Samal sir. Very good morning to one and all present here. I, Dr. Bhagyalakshmi Jaina, working as a Senior Assistant Professor in Electronics and Communication Engineering Department of Silicon Institute of Technology, Bhubaneswar. Welcome you to the AICT-sponsored AICT Training and Learning Academy, 5 days FDP on Internet of Things in 5G technology. It's a great pleasure for me to introduce our speaker, Dr. Sunil Somani. He is working as an associate professor, School of Electronics and Communication Engineering, MIT, World Peace University, India. He will be delivering a talk regarding technology enables in layers of 5G IoT. Dr. Somani has had student affairs at Dr. Biswanath Karad, MIT, World Peace University, Pune, India. He has more than 27 years of experience in teaching, research, and administration. His area of research includes wireless communication, digital communication, computer networks, and signal processing. He has authored more than 50 research papers in different international and national level reputed journals and reviewed conference papers in the field of communication engineering, communication network, wireless network, and converging different technology, telecom technologies. He has several years, he has been working as an active volunteer to serve IEEE Pune section in various capacities. Currently, he holds the chair, student activities committee, and vice chair, IEEE Communication Society chapter, IEEE Pune section for the year 2021. May I welcome you, sir, with a virtual bouquet. So now I request Dr. Somani that he will deliver the talk regarding technology enables in layers of 5G IoT. Sir, please.
Morning. Good morning, one all.
Good morning, sir.
Good morning and welcome, sir.
Yeah, good morning.
Bhagyalakshmi madam, please stop sharing your screen so that sir can share his screen.
Yeah, and you give me the sharing rights.
Yes, sir. I think now you can share your screen.
Yeah, yes. Okay, is it visible? The screen is visible?
Yes, sir. Your screen is visible.
Okay. So good morning, one and all. This is Dr. Sunil Somani, School of EC, MIT World Peace University, Pune. Actually, I first of all thank this Atal Academy, right, and the Silicon Institute of Technology, who has arranged this FDP on Internet of Things and in 5G technology. I thank Dr. Soumya for the rigorous follow-up, and Dr. Vandana that she has been following me from last, I think, week, right? So, and the organizers, right? And the organizers, and mostly the participant, right? Those who are actually here to listen to this particular topic, or that what is in 5G technology and how this IoT plays very important role in a 5G technology. So I first of all thank to all, and now I will start my presentation, right? So this presentation is around 1 hour. I will take 1 hour plus some minutes, right? So, and any questions are there that you can have in the chat box at the end, we can take that, right? So technology enablers in layers of 5G IoT, right? So actually, topic which I have selected because the layers which are there in a 5G IoT architecture, that what are the different enablers are there for this? Because as I had heard in last 1 or 2 sessions, right, it is related to IoT and 5G. So now it becomes an buzzword. Earlier it was a buzzword IoT. Now it is not a buzzword. It is in common terminology is there because it has been used mostly now in every part of our life. So actually, before my presentation, I will just tell you these are my outline of this presentation, that is 5G for smart and intelligent applications. So I'm covering some of the points, right, with some references which has been taken from the internet, from the books, from the various technology driven people are there, and those who are manufacturer, those who are researcher in that arena. So I have just sourcing from that, and I will be presenting. Now, if you see, this is in 5G, that is in coverage map worldwide. 5G is going on, some research is going on, some world. And in India, if you see, there is nothing as such is in 5G, but there is something which is going on in the 5G, but not in the front end. It is in the back end, the 5G things are going on. This European countries, right? So there is a lot of 5G deployment as well as the experimentation has been done, and the deployments are going on because of that new radio and all. This is an 5G coverage map, and sooner by 2021 end, actually we'll see that every corner having this 5G established, deployed, because the problem of the deployment of the 5G is because we are changing from 4G to 5G, lot of things has to be changed from the customer point of view or end user point of view, and it is very difficult to change all those things at a time. So as we know that whatever has to be maintained, but when we are shifting from 4G to 5G, that legacy equipments are not continued, right? We have to go for the new end user equipment, right? New end user equipment. But nowadays they are coming with the 4G and 5G enabled phone. That is what actually that the new terminology is coming nowadays about the 5G coverage, right? So before going to the next part of it, right, I will just actually tell you about one video of an Qualcomm, right? And this Qualcomm, how this they are saying this 5G and IoT convergence, or the IoT is there in a 5G, or 5G is there as a backbone of an IoT. So they are actually overlapping things are there. IoT is something which is actually doing as an end type of things, and whereas 5G will give you the coverage, right, connectivity throughout the world, right, throughout the devices. So that is what the things are there. So I will just share in my video, right? So
Picture a world where your house, your school, your workplace, your healthcare provider, virtually
Are you getting
everything
the sound?
can be seamlessly
Yes, sir. Yes, sir.
Okay.
integrated, connected in a network that has one goal: to enrich your life. Guess what? That transformation has already begun, thanks to 5G. The Wired Brand Lab recently talked to Qualcomm Technologies, the world's leading wireless technology innovator, who has been at the forefront of the decades-long R&D, standardization, launch, and expansion of 5G. We wanted to learn what the future of 5G holds by asking the trailblazers who are actually inventing the foundational technologies for 5G.
.5G is a communications fabric that's going to connect virtually everything. It's going to enable new use cases, higher data rates, lower latencies, and more responsive applications. So when we look at this decade of innovation, it's really going to be built on this 5G platform.
5G has been referred to as the new electricity. Just like when electric power became widespread and changed the world, that's how significantly 5G connectivity could revolutionize our lives. Think of it like this. Right now, a 4G smartphone connects you to your friends, family, and to information. But 5G takes the world way beyond smartphones. It can connect you to virtually everything.
It really is an innovation fabric for many future applications. It's going to impact things like healthcare, education, manufacturing. We're going to see new applications, new use cases continue to emerge.
Let's take a look. 5G is designed to deliver robust connectivity and a massive amount of data broadly and especially to underserved areas, increasing access to educational opportunities in those communities. Remote learning won't simply mean connecting students in classrooms. 5G is designed to complement and extend learning, allowing students to enjoy shared collaboration that was not previously possible. Sleek XR headsets are designed to deliver immersive experiences by augmenting on-device processing with the Edge Cloud via a 5G connection, allowing groups of students to take virtual field trips to historic sites or receive hands-on VR learning led by subject matter experts from around the globe, all without leaving their seats.
And that's our vision for Boundless XR, a mobile compute platform that combines augmented and virtual reality.
5G IoT also promises to make the teachers administrative so that they can focus on the thing that matters most, instructing their students. Always connected PCs can relay each student's progress to the teacher in near real time, so that teachers can adapt the curriculum to each individual's mastery of a topic.
The application of 5G and IoT to education is only just beginning. As we look 5 years into the future and 10 years into the future, there's going to be a continued evolution, both on the computing side and the 5G communications side. This will enable more immersive XR experiences for the students, and really a learning experience that can be more adaptive and self-directed. In healthcare, 5G connected wearables can be utilized to enable remote patient monitoring and data that can be shared with doctors and nurses in real time.
At-home medical exams and virtual consultations are poised to help patients receive greater access to healthcare.
5G connected hospitals can enable improved efficiencies and increase patient outcomes based on faster information flows.
For example, connected medicine dispensers could monitor daily prescriptions and aid healthcare workers in providing a higher level of personalized care. One day, 5G's increased connectivity may even unleash data that can be used to develop your digital twin, a digital model that could be aggregated with the medical data of similar patients to spot predictive indicators of common issues like coronary heart disease or hypoglycemia. In medicine, a field where every second counts, this could help doctors respond earlier and improve outcomes.
Data also plays an incredibly important role in manufacturing. A digital twin of a factory enables actual monitoring and replicas of the physical plant. This enables predictive maintenance, increasing the uptime where the equipment is operating at peak efficiency.
That's the promise of 5G, to help manufacturers and employees increase productivity while enhancing efficiency and safety.
People used to think that high reliable, low latency communication was only possible with wired communication links. With 5G, we're able to improve the reliability and decrease the latency. This enables wireless to move into applications like industrial IoT, enabling dynamically reconfigurable factories.
5G will also deliver precise asset tracking and routing that is built to unlock the full potential of just-in-time manufacturing, a lean form of inventory management in which factories can track parts that are en route to the assembly line to help ensure that they receive the correct parts at the precise time that they are needed. This maximizes inventory utilization and efficiency. As 5G connected manufacturing realizes these new efficiencies, it can free up time so that workers can make smarter, faster decisions about production and focus on more complex tasks. For instance, thanks to 5G's impact on the intelligent wireless edge, AR glasses with virtual overlays could help them execute their tasks, like repairs, with better precision and efficiency.
What excites me most about the future of 5G is applications and devices that are only now beginning to be imagined. That's why at Qualcomm, our job is not just to build 5G use cases, but really to design a platform for future innovation.
Hello, sir. You are not audible.
Sorry, sir. Okay, this is then 5G is the video, right? It is then related to this Qualcomm, and the Qualcomm is the main manufacturer of a lot of, the back-end hardware, right? As well as the various technologies which has been there. This is just a video of the Qualcomm, right? Now, I'll share my screen and we'll go to the next slide. Right? So the 5G world map we have seen, and this is a broad set of intelligent applications. Now by this video, whatever it has been shown, from this video, we got to know that a lot of technologies are there that is actually connected. So it is said that the 5G is nothing but is a communication fabric. Now, when we say the communication fabric is there, so each and every point in the fabric can be connected, and the 5G giving that particular platform for the connectivity, right? For the connectivity. So are you able to see this?
Yes, sir. Yes, sir.
Yeah, okay. So this is a broad set of an intelligent application, like whatever it is, industrial automation, then it is in predictive maintenance, defense, right? Intelligent buildings are there, and smart city, and everything, whatever today we are saying is a smart and smart. Actually, it is having the combination of an IoT as well as the networking, and the networking is now 5G enables a lot of things, and 5G enables a more capacity, right? Whatever the things were there in a 4G or 3G, actually it is capacity is very less. But because of this 5G, actually this volume of the data or volume of that particular application we can connect, right? And that is why the 5G is coming into a very well coming. The smart city application. So I say anything with the smart, right? So there is a smart automation, there is a smart healthcare, there is a smart sewage system. So smart city is one of the things, and in that smart city, there are a lot of smart things are considered, and because of that, the city becomes smart, right? So that various applications are there in a smart city, right? Then smart grid. This is another arena that is an energy related thing is there. So whatever the energy you require, that much energy will be supplied to your house, right? So that is totally sensed by this sensing system, and accordingly, that grid will give you, empower you that particular power. In India, it is not that much. It is in smart grid things are there. It is coming up, but there is something called that is a type of an energy meters are there in our house, right? That is sensing your power related things, and accordingly, it is also indicating to the nearest that would the MSCB center or whatever the energy centers are there, that what is the power consumption by this particular house, right? That is, prepaid meters are there, but there are something called meters are there where it is connected through GSM directly. One van is going through your colony and it will take all the readings of this particular people. Now it is actually doing like manually. The people are coming and they are actually getting the reading, right? But this will be there is a smart grid. Smart agriculture, right? So this is a very intelligent application which is coming up. Then the new knowledge, and very important is in predictive maintenance, right? So this maintenance, predictive maintenance based upon the data, based upon the legacy of the data, actually you can predict the things, and accordingly you can get the things better, well informed, and because of that there is no problem will be there in the future. There is no shutdown will be there in the future, because you know in advance that particular thing. So these broad set of intelligent application, you just add on, there are a lot of applications which are coming up nowadays, right? Because this internet of things, now it is not a buzzword, I said it is a normal, right? So anybody who is manufacturing anything, right, it is assuring that there is the connectivity, right? There is the connectivity feature in that particular gadget or whatever that manufacturing the product, it is there. So by default, whatever the things are coming up now, it is having that connectivity feature as an inbuilt, and because of this connectivity feature, it is possible, or it is always ready for connecting to the internet, connecting to the network, that particular gadget or that particular device, which we can say. Right? Because of this intelligent application, these are the enabling advanced technologies are there, right? Advanced data, then it is in computer vision, GPS, that is global positioning system, smart devices, right? Cellular wireless access network, right? And management of the data, right? That is a very important enabler is there because of this particular 5G and these intelligent applications, right? When we say intelligent applications are there, so what intelligence is there, that is totally based, that intelligence will enable these technologies, because we want intelligence means it is an active type without any human intervention, that whatever the systems which you have been actually keeping, that system will take care of their maintenance, take care of that whatever the data should be sent based upon the pre-written algorithms are there, and because of that actually this intelligence, but for that intelligence we are having these type of an enablers are there for that intelligent application, right? Intelligent application. So now, as we know that estimated device on Internet of Things in 2025. So this is what the expected things are there, right? By 2025, it is said to be around 80 billion, right? 80 billion devices will be there, right? 80 billion devices. Now, world population is around 8 billion. So every individual is having 10 devices per person, right? 10 devices per person will be the actually the speculation of that what are the Internet of Things or IoT devices are there in case of 2025. 75.44, it is around 80 billion. Now just imagine that 80 billion devices means one person is having 10 devices along with him. So you can just list it out like now actually you are listening to this one, right? But in the neighborhood of yours or in your personal area network itself, you can see that around 5 to 6 devices are there now itself, right? Now itself of every individual, right? Of every individual. And it is said 8 billion devices, sorry, 10 into 8, so 80 billion devices be there. That is the growth, right? That is the growth of an Internet of Things that I said. Everything, whatever it is manufactured now onwards, right? Now means actually 16, 17 onwards, that is having the connectivity. That is having the connectivity feature. Now, because of this connectivity feature itself, it is ready. That product is ready for connecting to the network, right? Connecting to the network. Now, when I say connected to the network, it may be in personal area network at the start. Then it can be connected to the Wi-Fi, right? Then it can be increased to that actually that whatever the range is there of that connectivity of the device will be increasing and increasing. And network connectivity is there, and network to network connectivity is nothing but two different networks, three different networks are there. That is nothing but internetworking, and that is internet, right? That is internet. So internetworking is there, and this because of that things which are having the connectivity feature inside, and they are having connected to the internet. So anything which has been manufactured, it is having this particular feature now. Without that, that product will not be survived also, right? Because anything you just consider in your mind, that particular thing is having the connectivity. That thing is having connectivity. When it is having some data, when it is something which has been monitored by that particular gadget, right? So that will be connected to the internet. So connectivity is there. Because of that, because of this IoT, the devices increasing, and this particular thing is increasing, and devices are there, and computing, you can say the things are there, that is go on increasing, right? That is go on increasing. So this is just a speculation traffic of 10 devices. Now when 10 devices are there, 80 billion is there. So what will be the traffic? It is a massive traffic, right? It is a massive machine to machine traffic is there, because these 80 billion devices are talking to each other, right? Because of that, you can say that what will be the traffic for that, right? Now, based upon this massive data, right? Massive data and massive this IoT expansion is there. Because of that, there is one Ericsson's white paper is there, which is indicating that one 5G network with 4 purpose IoT connectivity segments are there. Now, IoT has been divided into different purposes. Based upon the purpose, there is a classification of an IoT, right? So this is one is a massive IoT. The second, it is a broadband IoT. Third is a critical IoT. And fourth is an industrial automation IoT, right? This is what actually the classification is there based upon the connectivity segment, IoT connectivity segment, and IoT connectivity segment, as well as that what is the criticality of that particular connectivity is there. Whether it is an priority wise, whether it is a very important thing, based upon that, actually there is a division, and that is a massive broadband, critical, and industrial automation IoT is there. Now, when you consider this massive IoT, so low cost devices. So there are, I said that any simple device of around, you can say 50 rupees or 100 rupees is there, it is also having the connectivity is there. Because now these low cost devices, I mean to say, is suppose an wireless sensor nodes are there, right? That is an which is a deployment of this wireless sensor node is not an only 5, 10, 15, it is millions of actually these devices are deployed. Now, when these devices are deployed, millions or billions of the devices are there in some critical application, right? So whatever that cost of that device should be as low as possible, that is the requirement, because then only we can have the massive deployment of this, right? So these are all low cost devices. Small data volumes are there because they are handling a very small data volume, and extreme coverage is there, right? Extreme coverage is there. That is what actually the things which are coming into this massive IoT. Whereas when you go to massive IoT, means it is what you can say a narrowband type of an IoT, right? Then when you go to the broadband IoT, they are expecting that is high data rates, not a small data volume, it is a high data volume is there. And the rates of that particular thing is also high. Large data volumes to be considered, right? And low latency. Now, there is an extreme coverage here. It is a low latency is expected in that case of a broadband IoT. Best efforts you can do. Then critical IoT. When the critical IoT is there, it is bounded by latencies, right? It is bounded by the latencies. And this is ultra reliable data delivery is expected in that application, and ultra low latency is expected. So that is what the critical IoT applications are there, where it is a real-time decisions we have to take, right? When real-time decisions you have to take at that time, whatever the latency of the data which is actually coming to the base station, it should be a very low, right? Very, very low. And this 5G is providing that it is less than 1 millisecond. That is what expected by the 5G, right? So that is ultra reliable, low latency type of things. That is a critical IoT. And then finally, it is industrial automation IoT is there, right? Industrial automation IoT, which is Ethernet protocol integration. Then it is a time sensitive networking, clock synchronization as a service, right? I think in that video we have seen that industrial automation. So now everything digital twin of industry, digital twin of a human being, right? And based upon that, actually you are controlling from somewhere that whatever the data it is coming. So, but in case of an industrial IoT or industrial automation IoT, this Ethernet protocol is there. Right, so this is one particular layer, right? One is this is in types. These are the four different segments are there of an IoT connectivity segments are there. Then in between it is a network slicing, network exposure, network data analytics, device positioning, device battery life. These are also the concern as far as this IoT is considered, right? Now, if you see this particular example, in this example, right, in this example, it is shown that when the 4G is there, this 4G network is there, and this is a 5G network is there. Right, because of the bandwidth, I can actually switch off my video, right, so that I will not be disconnected. Thank you. Now, if you can see that this is a 4G network and this is a 5G network. Now, up to 4G network, we can have these two things, right? Massive IoT and broadband IoT with LTE, right? And with the narrowband IoT is there, it is 4G network. But if I'm going to this critical IoT as well as the industrial automation IoT, actually the 4G network is not supporting that. That is not capable of that, right? So the capability boost is there in 5G era, and that comes like a critical IoT introduction with the 5G new radio and enhanced with the 5GC, and industrial automation IoT introduction with the 5G NR. So because of this 5G new radio and all, the capacity has been increased in a so, and whatever that main important thing is in critical IoT is the latency that has been taken care. And because of that, we can take the real-time decision properly, and this real-time decision will make the things, whatever it is there, that particular functionality to happen, right? So this is 5G networks is in public domain and non-public domain, so there are variations are there, but from 4G to 5G, how this particular network. This is, we are talking about that whatever this paper, Ericsson's white paper, it is related with the, mostly it is a cellular IoT type of concept, right? In cellular IoT, this massive IoT, broadband IoT, critical IoT, and industrial. This is the division, right? This is the division in case of the cellular IoT. Again, IoT connectivity has been changed, or it has been classified as a cellular IoT and non-cellular IoT. That we'll see in coming slides, right? But this is the actually the important things. And what is the industry digitization with the cellular IoT? Now you can just imagine which particular sector is not touched upon, right? So entertainment, automotive, railways, manufacturing, utilities, forestry, agriculture, public safety, this media production, right? Then transportation, smart city, right? Various sports, healthcare, construction, oil and gas, water housing, right? Airline, maritime. So it is what actually the most of the 99% of all sectors which are there, utility sector as well as that corporate sectors are there, that has been taken care, that has been taken in the cellular IoT. So this is what all industry digitization is there in this particular one. So this is a very good paper that is on February 2020, the Ericsson paper, because they are also into that particular IoT, because they are into a cellular IoT more, because whatever the switches are there at the back end, that is of an Ericsson, right? That is of Ericsson. So they are taking care of these particular IoT things are there, right? So this is a very important one where this our cellular IoT has been converted, or I have been classified into these 4 IoT types, right? IoT types. Now, based upon this IoT, right? Based upon this IoT demand, right? IoT demand. So if you can see here, what is the enabler in this? This IoT enables mega growth in semiconductors, right? Because of this IoT, which is like I have shown in 2025, it is around 80 billion devices are there of an IoT devices. Now, when I say IoT devices are there, actually what that device is made up of, it is in semiconductor industry, right? It is in semiconductor industry, and the rise of this IoT semiconductor, if you can see, right? What is required in IoT as an end device of an IoT, it is what IoT MCUs are there, microcontrollers are there. Various microcontrollers are there, various things are there. I'm not talking about any special type of a controller, but based upon the application, based upon the scenario, actually, we are selecting the microcontrollers, right? So the heavy demand of an IoT microcontrollers is there. And it is said that from 2019 to 2025, this speculation of the growth is like in 19, it is an 18%, but in 2025, it is a 29%. So 11% of a growth, right? Which is expected in the semiconductor industry because again, 19 to 25, 6 years are there. If you can see that particular bar chart, now from 19 to 25, how many IoT devices are added? Based upon that, every IoT device you require the chip, right? Without that microcontroller chip, actually this IoT device is because it is in the heart of an IoT device, right? So this MCU market has been increased from 18% to 29%, right? So this is the MCU penetration is there, which will be increasing 29. Means around 11% is the increase in that particular penetration, right? Then if you can see the second way, this is just a microcontroller, right? This is just a microcontroller, but when we say IoT totality, right? There is an IoT connectivity chipsets are there. Like I said, that every IoT device is having a connectivity because these all IoT devices are there. 99% are wireless, right? Wireless are there, right? So only in industrial IoT somewhere that Ethernet is used on the back end, right? But everywhere actually this when we say the IoT device is what wireless enable. Right? When we are saying wireless enable, means there is a IoT connectivity chipsets are there, right? IoT connectivity chipsets are there. So I will show you that landscape of 21 plus connectivity standards are there of an IoT, right? From cellular IoT to non-cellular IoT. This is a connectivity, you can say the classification is there, but around 21 plus connectivity standards which are available, which are there based upon their need, based upon their purpose, based upon that what type of a data, based upon what type of a range, right? What type of a packet size, right? What is the range you want, whether it is a near field type of things or whether you want around 10 meter, 25 meter, something like that. So that totally based upon the application to application, the connectivity standards are varying, right? Connectivity standards, and you can choose the standard based upon your application, like the 4G, 3G, 5G, LoRa, NB-IoT, VSAT, 2G. So these are all, this is in 21. So again, when I say chipset is there, there is a connectivity and there is a semiconductor required, right? Now we are talking about, it is the intelligent type of an application. When we say intelligent type of an application, we require now this AI is coming into picture. Like yesterday, Vandana has said about AI IoT is there, AIoT is there, right? Now, when artificial intelligence is there, there is an AI chipsets are there, right? IoT AI chipsets are there, which has to be taken into consideration while you are manufacturing that particular end device, right? IoT end device is there, right? IoT AI chipsets are there, and you can just see that the growth rate of this IoT AI chips are like it is a 22% growing at a CAGR, right? 22% is the growth, right? Is the growth of this AI chipset, because as we know that whatever the future is, that it is an intelligent future, right? Without any human intervention, right? And whatever you required is what? Automation, right? Automation is there. So IoT MCU chips is around 11% are there. It is a growth from 18 to 29%. But from as far as an AI chipset is there, it is more than that. It is a 22% is the growth, right, from 2019 to 2025. That is the huge demand. That is the huge enabler, right, as far as the IoT semiconductors are required. Because when I say that IoT goes on increasing, right, devices goes on increasing, the semiconductor industry also goes on increasing, because these are because manufacturing of that IoT device itself is the semiconductor industry. And you can see that IoT AI chipset is going 22%. So that is another arena where this IoT is going on and this semiconductor industry going on. Then when I say microcontroller, then connectivity, then AI into that, and finally IoT security chipsets and modules are there. Because as data goes on increasing, right, whatever the things are going on increasing, right? So that data security is important, right? And that data security is there, that has been actually given by this IoT security chipsets and modules are there, right? These are security chipsets and modules are there in case of the security kind of things for the IoT in totality, right? So this is something like towards a hardware root of a trust, right? It is a trusted platform modules, then secure element, hardware security modules, and physically unclonable functions are there. So that is what the requirement is there as far as this IoT security chipsets are there. So you just see that IoT enables the semiconductor growth huge by 2025. Again, the first target is a 2025, then 2030 and all. But the immediate target is a 2025. And you can just see that what is the growth rate, right? What is the growth rate? Because every gadget, everything which is manufacturing, that manufactured by these particular features in it, right? Without that there is no manufacturing as such now, because you require that everything is required to be connected, because it is a data capturing type of things, right? Whatever the devices which are there, it is a data capturing, and this data capturing required, right? Data capturing required the semiconductors. So this is the growth of the semiconductors which are coming into a picture. So there are a lot many, the figures are there as far as $1 billion, $1 trillion are there, but I will not go into that dollars. But here, as far as the technology things are considered, this is the growth, and this is the opportunity to investment also. If those who are investors, so you can invest these things into it. This is coming in this, the very important, the report is there, and from that report, which has been published in our April 21 Electronics for You, so that is I have taken from that. So this is an IoT semiconductors, growth of an IoT semiconductor, huge one, right? It is a huge one, right? Like we can say that what is an 5G IoT in architecture? Now, when we say that 5G IoT architecture is there, it is a layer 1 to layer 8. Right, layer 1 to layer 8 is there. This is an architecture, right? This is an architecture which starts from the physical device, then device to device communication, means that is in connectivity. Edge computing, right? Now people are talking about like whatever the things we are sending to the cloud, sending to the fog, right? And then you are getting the decision. So there is a latency in the decision to be taken, decision to be delivered, action to be taken. That's why in future, means by 2022 or 2023, everything will be there at edge only. So edge computing is that layer 3 which is there, right? Then data storage, which is a layer 4. So computing will be done, everything will be done, and if it isn't, some data has to be there which has to be stored for long run, it will be stored on the either on the fog or on the cloud, right? It is a data storage. Then it is a network management, that is a layer 5. Right, it is a data analytics, cloud computing, network management. So this is a layer 5. So whatever the data which has been stored, right, which has been stored, that has to be actually now going into the further layer, which is the data analytics, right, cloud computing and network management. This is a layer 5. And layer 6 is your application, right, your application. And layer 7 is in collaboration and processes are there, because without collaboration, this architecture will not be there. The heterogeneous things will be there that has to be connected, right? That has to be connected. And without collaboration and different memorandum of understanding of this particular collaborating agency, right? Without that, this architecture will not survive. This architecture will not viable. That's why the collaboration and processes are there. And finally, it is a layer 8, which is in security, right? Which is the security is the prime concern, right? Whenever this security comes at the end, because the first thing is like whatever your data is there, that has to be integrated throughout the network. It has to be reached out to the destination reliably, right? Once it is a reliable communication takes place, then we can talk about the security. So security comes at the end, because first thing is like whether the data will be sent, data will be received or not at the receiver end reliably. That is the first our prime concern. Once that prime concern is actually fulfilled, then we can talk about the security. So that is always the things are like security is talked afterwards, right? Because first we have to see that whether it is a reliability is happened to be. If reliability has happened, means there is a 100% assurance is there. My data which has been collected from one particular point, that has been reached to the destination, right? So that is reliability. Then Once it is reliability is been achieved, then we can go for the security. That's why this layer 8 is the security. This is an proposed 5G architecture, is the IoT architecture is there. Proposed means what? It is now coming into picture, but at different layer, different things are coming up. Now every layer, right? Every layer we are having a lot many enablers are there, right? As in physical device, when I say in physical device itself, that semiconductor industry, whatever we have seen, that IoT, smart IoT devices, how to make that smart as well as in cost-effective IoT devices are there. That is very important thing. Right? The things which are chips which are coming up only for the specific application, why to go for the bigger one? Why to go for the, suppose the 16-bit controller? I can have the 8-bit controller also. I can have the size of that particular controller is as small as possible, because whatever the functionality which has to be considered, right? It is a limited functionality. So I can have the specific type of an chipset I can manufacture, right? And that has been exclusively used for that purpose of the application, right? So there are a lot many enablers are there as far as the devices are concerned. D2D communication or connectivity, I said 21 different standards are there of connectivity. 21 plus standards are there for the connectivity from the one end to the other end, right? Wired connectivity, wireless connectivity is there. So there are 21 plus connectivities there. And in that, again, we are having a various techniques, technologies we are used, right? And these technologies are all the time, it is enhancing the feature things are there of that, so that they are competitive with each other, right? They are competitive with each other. So 21 plus things are there. Edge computing, right? That is a very important feature, or you can say the part of your total IoT chain. It is right. It is an edge computing. At the edge only you can have everything computed, right? So no need to go to the cloud. No need to go to the. That's why before cloud there is a fog computing comes into picture. That fog computing is also called as now edge computing, because the fog is in between that cloud and the actually the end device is there. But this fog is now coming to the edge only. So everything is done at edge computing. So data storage, various data storage capacities are there, various techniques are there, various technologies we are using for the data storage, and how optimally the data store is there, how optimally things can be done as a data storage, right? And the network management, so that is NFV, network slicing, that everything comes into a picture, and data analytics, right? Data which has been getting from, because huge data, big data analysis or big data, that type of concept is coming because of the huge data, massive data which has been actually generated by this IoT, devices, and this data which is intelligibly connected, communicated to the destination, right? Destination, and analyzed, and based upon that analysis, actually you will get some decision out of it, and that decision will be again forwarded back to the controlling action, and the control will be taken for that, right? So that is an application layer, right? That is an application layer, and various application things are there, and then security is the concern. Various security standards are there, various security mechanisms are coming, various security algorithms are coming into this, so that actually my data will be secured, but it will not require more, the space, right? It is an optimally done, right? And because of the optimally done, because when we say security, we have to add on something in that, overheads in that particular one, right? So that optimally how we can connect, how we can curtail it down, so that is taken care in this particular. This is just a simple way to explain the 5G IoT architecture and different layers in that IoT architecture, which gives you different enabling technology, This is one paper, right? One paper which has been given from ResearchGate. Right, this is another one. This is a multi-tier architecture is there of an IoT, 5G IoT. It is a multi-tier architecture is there. If you can see here, it has been done as a front hall. This particular things are coming, like it was smaller cells, right? There is an antenna, there is a peer-to-peer communication, air interface, right? Node-to-node communication, right? This is coming in the field actually, right? And it has been connected to edge server for edge computing and all, right? Right, so this is at the front hall, right? In a back hall, it is a centralized this baseband unit is there, right, which is again converting H server. But this is connected to now, this is a smaller cell, right? This is a small cell, but this internet which has been connecting, and this is a macro cells are there. Now, if you can see, this is a very simple way in a home or end user equipment is there, which is called femto cells, right? It is in femto cells are there. Like whatever, now I have been connected to my Wi-Fi to this particular laptop, right? And this Wi-Fi is connected to various things in my house, right? So various, you can say laptops are there, some devices, smart devices are there, mobiles are there, right? That everything is connected. Now this cell is, it is related to your personal area type of network, which has been connected by the femto cells, right? It is a femto cells, then macro cells, the small cells are there, right? So macro cells, and this is the what you say, the of the cell, which is a femto cell, which is used for a personal area network. Now, how they are connected? This is connected to the core network, right? Core network, and again the internet. So internet is there at the backbone, right? Core network is there, which is connected, and internet is the backbone, and it is connected to this. This is again, this is one femto cell. That is an end user equipment is something like this is, and metro trains are there, right? Metro trains or bullet trains are there, which is also having the data. Whatever these bullet trains are there, if it is an unarmed, that is unmanned bullet trains are there, it is everything will be taken care by the data, right? Everything will be taken care by that, where that position it is, right? And what is the speed, that based upon that data, that whatever the roadside units are there on that particular track, that will take care of the operation of that end user equipment. So this is again a multi-tier architecture of 5G IoT, right? 5G IoT. So IoT is the major role playing, and 5G is the connectivity role has been played by this 5G network. So this is something which is an you can say it is a multi-tier architecture, right? Multi-tier architecture. This is also very good paper, right? It is an IoT for next generation smart systems, right? So next I consider, this is another way which has been indicated by just actually this hype cycle for IoT standard protocols are there. Now this timeline which has been given, and various protocols are there in this particular one. So it has been hyped in this, that is the ultrasound, then it is an CMA risk constrained CAP protocol, right? This is a macro OS, that is an IoT, eSIM, that is an electronic SIM cards, right? Narrowband IoT, Thread, Sigfox, Doctor. So that various LoRa, OPC, LTM, IPv6 and all. This has been hyped, right? Standard protocol hype, and now it has been actually coming up as an, steady state type of things are there, right? Based upon what type of information or what type of connectivity you required, right? So you are getting this hype cycle. This is a source by Gartner, right? And this particular thing has been given. So it has been hyped like this for this peak of an inflation expectation, right? And then afterwards, this slope has been actually going a stable one, right? So this is a hype cycle of an IoT standard and protocol. So various IoT standards, various IoT protocols are there, developed by 2020. Now it has been, the massive deployment is there, right? And from that deployment, the data which has been collected and data analytics is the next role which has been played. So maximum things of an IoT standards and protocols are now stabilized, right? Stabilized based upon the various applications are there, right? Based upon various applications. This is what I said, that IoT connectivity standards are there, 21 plus standards are there, that is IoT, cellular IoT and non-cellular IoT. So this is a basic classification between that, right? And in cellular IoT, this legacy, which is a 2G, 3G, 4G, 5G, and this is what the 5G. We are talking about the 5G IoT is there, that is 5G is nothing but the cellular IoT connectivity it is. But other than cellular, there are various non-cellular connectivities are also there. But if I say the 5G network is there, right? 5G is there, which is in cellular connectivity, which is there as a legacy one. That is one. The second type of classification is this is a legacy licensed, and in a license that is low power, that is LTE, M and NB IoT. But in non-cellular IoT, we can say that WPAN, that wired network, unlicensed LPWAN. This is yesterday somebody's talking with this WNAN, then WLAN, and the satellite for the higher coverage, right? Satellite for the higher coverage. VSAT, WLAN it is Wi-Fi, WLAN is Wi-Fi and others. For unlicensed LP, that is low power, that is LoRa, Sigfox. For wired connectivity, this Ethernet and all, these are for wired, and rest is that is in wireless, right? And WPAN, that is wireless personal area network, Bluetooth, Zigbee, Z-Wave, these are the connectivity standards are there. So now the second half of that, that is IoT connectivity is there. So this under IoT connectivity, these 21 plus standards are there, which are existence, right? And for that, you required a huge, semiconductor requirement is there, because you are having this chipset is for different connectivity, different chipsets are there, right? And because of that, you required a lot, right? So this is an IoT connectivity standards are there. These 21 plus connectivity standards are there, right? This is what the expected things for 5G technology is driven by what? Driven by that availability. It is full availability of the network. 99.99999% availability. Up to 10 Gbps data rate. So 10 to 100x improvements from 4G to actually the 5G network is there. Very important is in 1 millisecond latency, 100% coverage, right? 1000x bandwidth, right, per unit area. 90% reduction in a network energy usage. But again, this 90% reduction is not rightly taken in 5G. That's why that 6G coming into a picture with the reduction in the energy usage, right? Up to 100x number of connected devices that is there, that is per unit area when you compare to 4G LTE, and up to 10 years of battery life for the low power IoT devices. So that is what very important, the specifications are there. This 5G technology is driven by, right? 5G technology is driven by. Right? Access to the for smart and intelligent application that is upcoming, whatever intelligent application we have seen, smart cities, smart transportation, advanced agriculture, and e-health. So enable a major machine type traffic, right? It is a machine type traffic because everything which has been generated by the machine, right? Machines type. And this fifth generation technology is an impact, right? So significant and fundamental change to 4G is what? It will handle the voice, data, video, and MTC traffic. So triple play means it is in multimedia things are there, right? It is in voice, data, video. But along with that, MTC, that is a machine type traffic which has been generated by these IoT devices, by the machines, right? By the machines, and machine is speaking. Machine to machine communication is there. So that machine type of traffic which is there, and extended frequency of an operation, because it is not possible with this whatever the 4G things are there, that particular you can say the spectrum is not sufficient, right? You have to have the more spectrum is required, and that's why this new radio frequency of operation is there in this particular case, right? So this is an access for. Now, as far as machine type this communication is there. Now, if you can see on the right hand side, these are all connected vehicles are there, or you can just consider some autonomous vehicles are there, or it is unmanned vehicles, right? Data from sensors. Now, every car is having, it is said that for the Mercedes-Benz, right? Mercedes-Benz around 100 plus sensors are there, 70 plus, 75 to 100 plus sensors are there in one particular car, right? And that data is generated from that car, which has been controlled by that ECU inside, and that ECU is connected outside also. So what type of a data from sensors which has been generated, right? This huge data which has been generated. Now you take that into consideration or not, that depends upon what is your algorithm and what type of a data criticality is there. Accordingly, you are selecting that, right? So that is a data from the sensor, and actually commands and control signals to actuator based upon the data, based upon that whatever data you generated, taken decision, and based upon that your command and control signals have been given to the actuators, right? So because of that, you can see that incoming data from the sensor devices, right, and outgoing data from the actually to the actuators, that command and control signals are there for the actuators. So that is totally analytically done at the ECU end, and accordingly the decisions will be taken, right? So this machine type communication traffic, which is there, heterogeneous traffic patterns are there depending upon application. It is not uniform type of, right? It is not homogeneous traffic patterns are there, because application to application, the data which has been generated, traffic pattern which has been generated, right? It is varying. So that is different type, different patterns are there, right? Different generation periods are there. It is not generated at the same time, right? It is different times, slots are there, and different intensities are also there, right? Somebody is generating the data, it is around 1 kbps, but somebody is generating that particular one generating the data around 2 mbps, right? So intensity of that particular data is also varying, right? And that is a heterogeneous traffic patterns are there depending upon the application. It is a periodic, sometimes uniform, event-driven, stochastic type. Sorry. Stochastic type of things are there, and multimedia streaming. So heavy-tailed data is there, which is so the traffic characterization as far as to be handled, right? It is totally different. It is a heterogeneous type of pattern. It is there, and it is not possible, right? It is not possible in the sense it is very difficult to handle this type of a traffic, and for that actually the normal 4G network will not be there. So you require on 5G only, because the traffic pattern, right, heterogeneous traffic patterns are there, right? And the massive number of devices are there in that whatever the new applications are coming up. I will show you at the end that how that data will be generated, right? So you will understand that, right? You will understand that. So okay, quickly I will just unshare this, and I'll share one video from the Oulu University, right? Oulu University, and that things happen with the Nokia, right? Nokia has made that, and from that Nokia, that what will be the future of this healthcare industry? Now we'll say that healthcare industry is there, and this healthcare industry or hospitals industry, hospital only, right? How these hospitals are utilizing this 5G IoT, right? Utilizing this 5G IoT. Just I will share that video so that you will be again getting the three, because this is theoretical one, right? And real applications which we can see. Based upon that, you can just imagine that what type of the logistic is actually concerned in that type of traffic. Just a minute. Is it audible?
Mä oon lääketyöntekijä ja mun työ on lääkkeiden keräilyä ja niiden kuljettamista.
Are you getting sound? Just confirm me.
Paljon aikaa menee turhaan, että noin 2 viikon aikana on mennyt turhaan kävelyyn niin 25 kilometriä. Se on ajallisesti jotain 4 tuntia.
Efficient logistics is critical to any modern hospital. Beds, food, medicines, and advanced equipment must be in the right place at the right time. It's around the clock, and one that, done well, allows medical staff to focus on what they do best.
Our mission and task is to free the time of these highly skilled healthcare professionals to focus on people, patients, and to free the time from this dull, unproductive tasks.
Hospital, Nokia deployed its digital automation cloud, including its high accuracy indoor positioning capability. This helps staff chairs and other equipment in real time.
Tämä interaktiivisuus on aivan huikea. Tämä mahdollistaa laitteiden yhteiskäytön, erityisesti kalliiden lääkintälaitteiden paikannukseen.
Alongside positioning technology, The Nokia Digital Automation Cloud provides secure and reliable connectivity, and that creates the ideal infrastructure for mobile robots to assist in certain tasks.
Robotti on ollut meillä 2 viikkoa nyt töissä ja se on ollut oikeinkin kiva työkaveri. Se on helpottanut mun työskentelyä ja se on säästänyt tosi paljon mun jalkoja.
They can deliver medical equipment, medicine from the pharmacy, guiding people to the correct waiting areas in the hospitals.
To effectively communicate with personnel and each other, the robots take advantage of pervasive and with real-time access to medical data, they help ensure the correct distribution of medicine and the right dosage.
We can guarantee and reduce significantly these medicine errors because the robots will follow the tasks and instructions by these databases.
Practical benefit for the patient is that patient gets faster, more precise and more quality service.
That's about a Nokia digital cloud, right, which has been actually deployed at Oulu University, right, in hospital management. You can just see that around 45 kilometer is that arena of that hospital, right? So one person has to carry something from one end to the other end. It is around 45 kilometer throughout the day, and that has been totally removed by this automation, right? Automation, connectivity. Then it is a pervasive type of connectivity is there anywhere in that particular domain. So that is possible, right? That is possible using this IoT devices as well as in 5G things, right? 5G things are there. Right, so that is actually showing you that what are the traffic pattern and what is that industry which is actually getting through. So this is an MTC traffic characterization is there. So how this 3GPP, that's 5G introduction is there. We are now released 17 5G, right? So it is started with 3G CDMA, then it is in 4G OFDM and OFDMA is there. Absence of a compatibility and migration. So this is what, right? And when it is going from 4G to this R8 or to R15, that is released, LTE and EPC is there. There is an absence. Now from this R8, R15 to R17 5G, again, there is an absence of a compatibility and migration is there. So that is why we have to change the devices, and changing the devices is a very important thing as far as the technology advancement, and you have to use or you have to take care of the technology. If it is, then we have to go for the new devices. This is one just and simple application of an energy sector which has been shown, right? How this energy layer, the telecom layer, that connectivity layer, and the application layer, this the virtual network things are there on this particular one, and these are all, the cloud layers are there, which has been taken care by this application. Just to show this application from whether it is in gas or LNG or the electricity, this energy layer, how it has been connected. This is like something called smart grid technology, right? Smart grid technology is there, right? These particular distribution, how it has been done and how it has been used by this application layer. So this is just an example which has been given. Likewise, there are n number of use cases are there, right? Which is using both IoT as well as the 5G. As it has been said very well, the 5G is nothing but it is a communication fabric for all type of data, right? All type of data means all heterogeneous type of the data pattern is there that will be taken care with this particular 5G, right? This is an 5G introduction is there, which is again smart city, smart home. The requirements to support the voice data and video, support this IoT devices, allow devices and machines to interact with each other, right? So, and this finalized standard in 2020 that is there, right? Deployment has been started, and that is what I have shown you that the deployment that what is the total status of the deployment of 5G. So the paradigm shift from 4G to 5G is like it is managed machine type of communication or machine to machine traffic, and that machine to machine traffic has been increased a lot, right? Increased a lot because of the huge number of introduction of the new devices, IoT devices are coming into picture at any corner of the services which has been provided. We have that IoT device at that particular moment. This was, and when you compare with the 4G to the 5G, and right, so this IMT 2020 vision was there. Like if you can see the inner side, right, inner side is something related to IMT advanced, which is around 4G, right? And when we go to IMT 2020, you can see that these three types of things, like it is an ultra reliability and low latency communication, which is an expected one. So latency is less than 1 millisecond, whereas here it is in 10 seconds, right? So mobility, which is 500 kilometers per hour, that is expected. Spectrum efficiency has improved up to 3x efficiency. User experience data, this is EMBB, that is embedded mobile broadband data, right? And this is machine or massive machine type of communication is there. And this is what, these are the three corners of that particular pyramid. It is in the 5G. Area traffic capacity is megabits per second per meter square. So 10 megabits per second per meter. Peak data rate is around 20 gigabits per second, which is an expected in 5G, right? And user experience data rate is 100 Mbps is there. And network energy efficiency has been improved to 100x, right? 100x. So that is what the main advantage of this, or that is a vision, and that is actually, it is reaching to the vision of this IMT 2020, right? And this is a massive machine. So connectivity density has been increased to 10⁶ devices per kilometer square, right? 10⁶ devices per kilometer square. So this is a division. This is the evolution again, how in 1G, 2G, what type of a data has been there, 3G, 4G, what type of a data which will be handled, right? And 5G, you are having the smartphone, but it is in sensor plus machine traffic is more in case of 5G, right? That's why the cloud is coming into picture in the 5G. In this 1G, 2G, up to 4G, there is no cloud at all, right? So whatever is done at the server or at edge and at the devices. But in case of a 5G, we are having this cloud into coming into picture. This is to show that download performance of a wireless generation as you go from 3G to 5G. Network type is cellular network. It is a 3G, 4G, 5G. The rate which has been there, 384 kbps, 100 mbps for 4G, right? And 10 gbps for 5G. Now it is just shown like how long would it take to download the 2-hour long, right? It is Guardian of the Galaxy, that particular suppose movie. So if it is a 3G network, is there 26 hours which is taken. So you are flying from New York to Sydney, including check-in time. So you require that much hour, 26 hours, right? What you could do while waiting for this 26 hours, you can fly from New York to Sydney, right? If it is in 4G, it is 6 minutes. Run a quick mile, catch up on Facebook. So it is a 6 minutes, which has been just shown, right? But in 5G, it is 3.6 seconds only, right? 3.6 seconds. Ask, is it downloaded? So that is what the question you have. What you do in that particular time? So it is whether you can say, is it asked? Means it is like, and surprisingly, yeah, it is downloaded. So it is 3.6 seconds for 2 hour. That is long Guardian of the Galaxy. Suppose that is what the type is there of data which is to be there. So that is huge. You can say the downtime, right? Download performance is there 26 hours to 3.6 seconds. Just you can imagine, right? It is a 5G, right? So that is the performance. So why this 5G entities are there? It is a CRAN, that is a cloud-based radio access network. Then the 5G new radio, that is very important. So millimeter waves, 30 to 100 gigahertz operation. And this NOMA, that is a non-orthogonal multiple access, which is the multiple access mechanism which is used in 5G radio. And MIMO antennas, that is a steerable beam forming, is there in case of this 5G. That is because of that, actually we can support these many devices, as well as actually the whatever the speed which is maintained because of this 5G and because of this new radio concept, right? The cloud-based packet cores are there in this software-defined networking, network function virtualization, and network slicing, right? And enhanced cyber security and reliability. These are the few characteristics of 5G. This is what extended operation in millimeter wave spectrum, how it is, right? So there is a classic sub 6 gigahertz operation, and then 5G millimeter operation is there. So up to 6 gigahertz, whatever these applications, if you can see, below 1 gigahertz, this is a television, right? 1 gigahertz to 6 gigahertz, your Wi-Fi is there, right? Wi-Fi is there. That is macro cells and small cells are there coming into picture, right? This is a sub 6 gigahertz. And then the above 6 gigahertz, that is a new mobile spectrum. It is 30 gigahertz to 100 gigahertz, millimeter wave band. And that when we say that gigahertz is there, as my frequency goes on increasing, that whatever the size of that particular components are decreasing, and the cells, that is macro and small cells are there in Wi-Fi. Here it is in small cells only, or femto cells type of things which are coming into picture in this. That is an extended operation in millimeter wave spectrum. Right, so the 5G millimeter wave operation issues, like when we are using in millimeter waves, right? So there are operational issues are there because you are operating at very high frequency. So the propagation and coverage, right? So high path loss is there due to high frequency. I think free space path loss equation will tell you that as my frequency goes on increasing, my path loss is also increasing, right? So significantly reduced coverage of less than 1 kilometer because of that, right? Deterioration in propagation characteristics due to various environmental issues like humidity and rain, and susceptibility to blockage, right? Weaker non-line of sight paths are there, right? And limited in-building penetration is there, right? Blockage. So that is an operation issues are there. And coverage gaps are there. Whenever you are actually propagating this, there are some coverage gaps are there, right? How it has been solved? This is the solution for that, is we are using a massive MIMO. Right, so this massive MIMO, that is for propagation, whatever the problems are there because of millimeter waves, right? So that it can be sorted out, or that can be addressed very well by deploying this massive MIMOs. So high frequency, smaller wavelengths, small patch antenna dimension, and large sized arrays is possible. And that's why it is a massive MIMO implementation is more in case of 5G, right? Strengthen the signal using multiple streams, create the narrow or adaptive steerable beams with a high concentrated power. It is possible, and because of that multi-steerable beams are there, we can actually address very well. And this mesh networks are there. You can use device-to-device communication by bypassing the centralized. Not every time you go to the centralized base station and then again come back to that the peer or the device where you want to communicate. Rather than you can actually D2D communication is possible, bypassing the centralized base station, and use relays to fill coverage gaps. So this is something like a MIMO antennas are there. So 4G macro, this is the way that is in tower, and these are the array of antenna, but this is in 5G macro. So you can see this is around 100 elements patch antennas are there. And because of this, actually you can have the steerable beam type of multiple beams you can actually get, and this every beam will have some different application altogether. So that can be shown in this like this. Right, so this whatever the 5G macro multiple beams are there, that is going into this elevation vertical beam forming is there. Then it is azimuth beam forming, so you can actually connect to these particular building. You can connect the pedestrian. You can connect these the autonomous vehicles, right? Autonomous vehicles, and this is actually the coverage you will get because of this 5G 3D. Whereas 4G macro, you can see that limited things are there because of this. The steerable beam and MIMO, actually you can get a lot of advantage over that. This is the 5G network, which supplements with the mesh networking for D2D communication. And this 5G cost effectiveness, if you can see 4G base capacity, this relative capacity, right? And the cost. So this is an Ericsson, which has been shown that is 4G massive MIMO, it is used, right? But you can see that whatever the cost of per GP is there in 5G NR, it has been drastically decreased, right? Drastically decreased when you compare to the cost effectiveness of 5G, right? So that is not directly solution only 5G. So it is an hybrid access through Wi-Fi, LTE, and 5G, right? Wi-Fi, LTE means it is every technology is having its own benefit, right? Its own benefit. So it is better to have the hybrid things of an all Wi-Fi, LTE, and 5G. If you consider, you can cover the total thing. So if you can see here, inside it is in 5G and Wi-Fi, this millimeter waves are there. And this is sub 6 gigahertz range. And this is a gigabit LTE range is there. So it is finally the solution will be, it is in combination, which is a hybrid of all this technology, right? Now, again, this pyramid has been shown by this ITU, which has been taken, right? So it is something which is a three major solution, which has been 5G is giving, right? Is an enhanced mobile broadband. Then it is an ultra reliable and low latency communication. And this is a massive machine type of communication. So this is a smart, these are the usage scenario is there that is in smart city, right? Smart city in voice is coming into this one, right? But in case of the application range of ultra reliable and low latency communication, you can see that mission critical application like e-health is there, right? Right. Then it is a self-driving car, industry automation is there, and augmented reality. So it goes on like 3D video, UHD screens, you require a mobile broadband enhanced. Gigabit in seconds that you want to send. So this is what enhanced. Smart home or smart building is there. So this is a pyramid, which will three corners of this pyramid is showing the three major type of an application area where this 5G is supporting. And these are the characterization of this 5G is there where these particular things have been supported. This is again in different way. It is artificial intelligence, right? Super IoT, like smart things, all smart based application. And this mobile ultra broadband is there, augmented virtual reality and hologram. That is what the combination of an augmented reality and virtual reality you will get. So this is enhanced, right? It is a mobile broadband is there, 5G, and this is the massive machine type traffic and ultra reliable and low latency type of communication is there. And you are having an artificial intelligence in that to have the automation of this. This is just in another way, right? What is sub gigahertz and 1 to 6 gigahertz and above 6 gigahertz. Right, these are some 5G use cases. You just imagine like whatever the cases we have seen, these are the use cases. Transportation, you can take IoT, augmented and virtual reality, smart city traffic management, the manufacturing robotics, tactile internet, health, fitness and healthcare, smart grid utilities. The various government organizations are using now that for the different deployment of this, and a smart office, right? Smart office. These are some 5G use cases. When you see the mobile subscription by technology, like around 8.8 billion, that is by 5G is there. This is a spectrum. It is not considered IoT. It is just related to the subscription of the mobile. It is not an IoT traffic. It is right 2024. Just to give an example, like autonomous vehicle communication network, which are the particular things are coming into picture. It is just one autonomous vehicle, right? And this autonomous vehicle is moving on the road, right? These are the things which are coming into picture. So you are connected with the GPS through satellite, right? So you are connected with this nearby by 5G cellular. If it is a dedicated short range communication is there, it is Wi-Fi is connected, right? If it is in communication between vehicle to vehicle communication is there, again, this DSRC Wi-Fi is there. But if you want to take the decision at the edge only, so edge or foot computing, that is called the roadside units are there. They are taking decision and accordingly giving the control or the decision from that the data, right? And this road, then the network, and then finally the cloud computing is there if data has to be stored. So this is one autonomous vehicle, right? So what are the key issues in this? It's a data orchestration and this multimodal wireless connectivity. This is multimodal wireless connectivity. You can say the GPS, 5G cellular, DSRC, this fog computing, the network and cloud computing. So how this data orchestration and multimodal wireless connectivity, these are the very important issues as far as this connectivity to this is considered, and the mobility from one place to other place it is to be considered. And inside, right, inside there is a local communication called Bluetooth and RFID and all this for infotainment and everything is been done is there inside it. But when it is to be communicated outside, these are the all multimodal wireless connected things are there for every different features. simple car, right? This is a sensor coverage. What is the sensor coverage? What type of sensors are there in the car? If you can see that, if it is an autonomous vehicle is there, right? So these many sensors coverage are there. Like you are having a long range radars, lidars, various cameras are there, short and medium range radars are there, ultrasounds are there, right? Ultrasounds are there. So this is a sensor coverage. Like it is said like flood of data in AV, right? That Intel has been given this particular data, right? Means whatever this coverage we have seen, that GPS is there, sonar is there, radar, lidar, and cameras are there. So around 20 to 40 megabits per second. Like what is the data which is generated, or what is the flood of data? Means 4,000 GB per day. The data is generated by one driverless car. Just imagine one driverless car which is giving 4,000 GB of data, right? 4,000 GB of the data means what? It is around one driverless car is equal to 2,666 internet users are there, right? 2,666 internet users are there. So this is what one driverless car, this is the data that has to be handled, and that is not handled by a normal network, normal communication fabric, right? It is, that's why the 5G, and now the next movement is in 6G is there, but 5G is supporting this particular autonomous vehicles. But this is the huge data which is generated, Right? Before actually stopping here, I will show you one Intel's video only, right? One Intel's video that will give you again. So is it audible?
No, sir, the audio is not coming.
1 minute. The problem, I think. Just give 1 minute.
promises to impact our lives in all kinds of positive ways, even the way we experience
It's
large
audible, sir.
Yeah,
like
this is a
concerts
smart
or
stadium,
professional ball games.
right? Using this 5G
Imagine a
IoT.
stadium that was smart enough to lead you straight to the best possible available parking space, or where entrance queues moved faster because security screening is augmented by artificial intelligence, or where your ticket was scanned automatically off the phone in your pocket as you entered, while your favorite food and drink request was submitted and delivered straight to your seat. The stadium's custom app would provide you with exclusive, up-to-the-second stories about your favorite performers or players, action in the arena, and even let you view the action from a variety of angles throughout the venue, giving you the ability to be the director of your own personalized experience. With thousands of fans in the same stadium uploading high-res photos to their favorite social media sites at the same time, today's networks are often overwhelmed. But with 5G, every fan in the stadium can expect to have access to the services of a high-bandwidth, low-latency network that optimizes the experiences of today while enabling an entirely new generation of even more immersive experiences in the future. Of course, the new 5G era isn't just about smart stadiums. It's about improving our lives by enriching our experiences in any environment, from the retail shops in the mall to life on a college campus, or even improving the livability of an entire city, and just in time. After all, video, pictures, and other visuals are at the very heart of how we communicate in today's world, with the vast majority of data moving through today's networks already being video and media based. So get ready. The future is about to catch up to the way we're already living our lives.
I think this is in 5G, right? So, right, that is the data which has been generated from one car I'm talking about. Now, you can see that what are the data which has been generated from various events, right? Various events are there. So that can be seen, right? That can be seen very well using these applications or these things which has been developed by the various leaders in the world, right? As a manufacturer, right? Deployer, right? And technology driven, these entities are there, Intel, Nokia, and Qualcomm, right? Just I have mentioned a few, but if I can actually give you the something related to Tesla and all, so that is an Elon Musk, right? So this is again having the better one, but this is in 4000 GP per day. That is an per day. That is the data by one autonomous. The number of vehicles when it comes into a picture, whenever this Tesla comes worldwide, or this autonomous vehicle comes worldwide, and what type of data will be generated. And that's why to support that particular data, we require, right? We require this network which is having a high capability, right? Ultra low latency, handling the data with high, right? So that is requirement is there, and the IoT is playing a very important layer. Important level at everything is actually now IoT enabled, right? IoT enabled, because the thing which can be connected to internet, that is an IoT only. So whatever you talk about, right? So that is the way that is in flooding of data, which is coming. These are the concluding remarks, like the 4G, 5G is there, but 5G supports a multi-communication in sub-gigahertz range as well as the above 6 gigahertz range. 80 billion devices connected by 2025, that is the speculation, right? A new domain of millimeter wave operation is required, because otherwise you cannot go into the whatever the spectrum available to you. So that is a new radio, right? That is a new radio. And the propagation losses and coverage gaps are there. It has been addressed by deploying MIMOs and beam sharing and mesh networking, right? And security issues for massive M2M traffic, that is primary and secondary, that is two-level authentication or single-level authentication we can use, right? And autonomous vehicle is a very typical example of a 5G connectivity, having everything inside, right? Having everything inside, right? Thank you from my side. I think I have taken some lot of more time, but actually this particular topic is not restricted in 1.5 hours, right? You go on talking, and there are a lot of things are coming all the way, but I have tried to make up in this particular 1.5 hours. Thank you from my side.
Thank you very much, sir. It was very nice lecture. Thank you.
Thank you very much, sir, for such a nice and wonderful session. So there are some questions in
Yeah.
chat box.
Yes. How we can manage the state information of massive number of IoT devices, right? IoT devices. How seamlessly interconnection between heterogeneous networks can be implemented. How security and cyber attacks increase the privacy concerns. How to implement the effectiveness of the 5G data networking, right? So provide the core network with high flexibility and scalable SDCN. How to deploy IoT application, how dense heterogeneous networks are there, right? So I think these particular questions are related to the deployment of this, right? Deployment of IoT, how it is, right? But nowadays, if you can see that all these IoT things are there, which has been massive IoT, that is massive number of IoT devices, means what? The number is go on increasing. Like I say, it is around 80 billion will be the speculation of 2025. Now, how you can manage this? Yes, we can manage if it is having the network connectivity, a proper network connectivity, as well as actually the connectivity with the heavy data rate handling, right? If it is there, actually we can, and 5G is the solution for that, right? How seamlessly interconnection between heterogeneous network can be implemented. This, how seamlessly, because actually if I have shown one slide where the heterogeneous traffic is there, right? Heterogeneous traffic is there, and how seamlessly, again, for the seamless connectivity or for seamless interconnection of any network we require, right? We require the strong support of a backbone connectivity. That is very important, and that has been supported by various implementation schemes of an 5G, and because of that we can very well interconnect this. And that is the reason, right? That is the reason, if you just remember 2-3 years back, actually whatever the testing which has been done of this Tesla car in US, right? So at that moment of a time, that 5G is just an, actually this 2020 it has been finalized now, that whatever the standards are there or whatever the draft copy is there, and now implementation is going on, right? But when they have tested on a 4G, and that has been not supported. Sometimes there are accidents taken place and the connectivity was the problem at that moment of a time. So that is very important. And I know that for anything which has to be considered in case of an heterogeneous or homogeneous, right? The main important thing which is required is the connectivity. Seamless connectivity is an important factor, and that we have to take care, right? If that has been taken care very well by the proper implementation of that deployment of the 5G network, then there is no problem of a connectivity all the time. Now, actually, whenever I'm giving this talk on virtual conference, right, I'm getting one message sometimes, that is, there is an unstable internet connection is there. And I'm worried immediately, because if I'm getting disconnectivity, right, and to connect again, it will take some time. And if that it will take some time, may have something which is happen very rapidly in case of your real-time application. Here, it is just a talk is there or just implementation I'm talking about. But if you want to take some decisions based upon that, it is very important, the seamless connectivity. So that is an underlying principle has to be there whenever you implement anything, right? Anything as an heterogeneous network or homogeneous network, but the connectivity. So deployment of that 5G is very important. Very effective deployment is required for that, and that is possible, that to get this seamless interconnection, right? Deployment is important one. Deployment means what? Actually, at certain places means there should not be any bad or dead zone of that connectivity should be there, because if the dead zones are there in a connectivity in that particular arena, that may have that seamless interconnection will be actually void, and because of that 2 millisecond or 2 second data is very important, suppose that has been lost. So to get that, you have to have the overlapping type of a pattern which has to be taken place whenever we are deploying this technology, right? How security and cyber attack increase the privacy concern? Yes, it is. That is the concern, that is the challenge, right, to the 5G network also, that security and cyber attacks are there. increase the privacy concern? Yes, it is because whatever the data which is an important one for you, right? Sometimes the data that is important for you, that will be the garbage for others, right? But important for you, that if and that has been actually taken, right, by the attacker, that is really the privacy is breaching in that case. So we have to have a better security algorithm, right? Better encryption standards, which we have to have, so that the attackers cannot decode that data, right? And that way we can actually, the privacy which will be breaching, that will be minimized. I'm talking about that will be minimized, and that is the major challenge for this cyber system or cyber security developers, right? Developers, and that is the very important thing. How to implement effectiveness for 5G data networking? Right, implement effectiveness for 5G data networking itself is a deployment of a 5G network. If you are deployed properly, actually the effectiveness will be the outcome of it. If it is not deployed properly, means what? There is a dead zone. There should be a connectivity, that overlapping pattern, like whatever I have shown, this MIMOs are there, right? MIMO antennas are there. Whatever that beam patterns are there, these beam patterns, and the placement of the second MIMO antenna, it should be in such a way that it should be an overlapping one, so that there should not be any dead zone, right? Where there is a dead zone is there, then the problem is there. So to implement the effectiveness, right, we have to have the deployment proper, right? That is there. Provide the core network with highly flexible, the scalable SDCN. So I'm not getting this particular question, right? And I think how security and attacks are there. Right? So insert that. And is software-defined communication network may need complete reconfiguration in short notice? Yes, it requires transceiver beyond RF. How 5G can handle this issue, right? So now I think this 5G, which is something which is related to a new radio, right? New radio. And if I am handling the properly this new radio, that there is a problem, the software-defined communication network are there, that can be reconfigurable in short notice, but that short notice will be that whatever the timing has to be very a crucial role plays, right? Crucial role, and because it is a trans-receivers beyond RF. So how 5G can handle, right? Effective implementation of the 5G is the only solution for all these particular things, because inbuilt the characterization of 5G is as it is, right? But the things will be considered that that is a deployment is very important, right? Deployment is very important. I think I can whatever the submissions are there of mine, so that may satisfy Dr. Shravan Kumar. I think he has asked the series of questions. I think it is a representation of all, probably.
Yes, sir. Some things you can take offline also, no problem.
Yeah, no problem, no problem.
Are there other questions? Yeah, I think there are no any other questions. Soumya sir?
Yes, ma'am. No, ma'am. There is no more questions are there. So I think over to Dr. Bhagyalakshmi Zena.
Thank you, sir. It was a wonderful session by Dr. Sunil sir. Thank you, sir, for your excellent presentation with lot of visualization. As we all come to know about the 5G connected healthcare system and the 3 videos which you have shown, that is, one is Qualcomm's Smart Stadium and the Nokia Digital Cloud, is a really super. And we get some knowledge about the different intelligent application by using the smart grid, smart city, energy saving, and how the growth of IoT takes place by using artificial intelligence from 2019 to 2025. It was really good. So, and you show us what are the 3 different major solutions by using the 5G, and the different segment IoT connectivity, multipurpose takes place. So, sir, on behalf of Silicon Institute of Technology, I take this opportunity to propose a token of thanks for your wonderful talk. Thank you, sir.
Thank you very much. I think whatever the questions are there, that can be taken offline, no problem. I thank you all, the organizer team at Silicon Institute of Technology and the AICT and the Settle Academy, right, related to this particular FDP sanctioning, right? So I thank you all. And
thank you very much, sir. Thank you. It was very informative and very interesting lecture. Thank you so much.
Thank you.
Yeah.
I request all the participants that should be present that will be having our next session at 11 a.m. by Dr. Desmukh.
Okay, thank you. I can leave now.
Yes, sir. Yes, sir.
Yeah, I have taken some more time, so thank you.
No problem, sir. It was interesting.
Yeah,
no problem.
Yeah, thank you. Thank you.
Thank you.
Dear participants, very soon we'll be starting our next session by Dr. Madhukar Desmukh at sharp 11 a.m. We'll start. Let our speaker join.
So all the participants are requested to stay tuned so that we can start our next session very soon.
Hello, Deshmukh sir. Good morning.
हो.
Hello, good morning, sir.
गुड मॉर्निंग.
काय म्हणताय? तब्येत वगैरे बरी आहे?
बरी आहे.
ओके ओके ओके. आमचं काय चाललंय आता हे FDP चालू त्याच्यामुळे गडबड. कॉलेज चालू ऑनलाईन.
Good morning, sir. This is Soumya.
Yeah.
Sir, we have met.
Hello.
सर तुमचा आवाज थोडासा कमी येतोय.
Good morning, sir. This is Soumya.
Good morning, sir.
Sir, in fact, we have met at Bombay, in the year of, I think, 2016, with Bandana ma'am in one GISP
We
meeting.
used to go to some meeting, the GSP meeting.
Yeah, yes, sir.
Okay. Thank you. So,
sir, I will start the session very soon, within 5 minutes.
Yeah, there are 8 minutes still.
Okay, sir. 8 minutes. Yeah.
Soumya, you can make your video on so that he can recognize you. Once he will see you, he will be able to recognize you.
Yes, sir. Yes, ma'am. Yes. Even in my profile, in my WhatsApp profile pic, my photographs is there. Maybe, sir, may recognize me. So,
shall I? I mean, okay. Later on, I will share.
Sure.
I could not see you, sir, but you can switch on your video.
Okay.
मॅडम.
येस सर.
ऍक्च्युली हे आपले पुण्यातलेच लोक आहेत का बाहेरचे पण लोक आहेत?
नाही, हे सगळे तिकडचेच सर. हे ऍक्च्युली सिलिकॉन इन्स्टिट्यूट ऑफ टेक्नॉलॉजी ओरिसा मधले भुवनेश्वर. आणि आम्ही दोघं कोऑर्डिनेटर आहे, कारण ओळख होती त्याच्याशी चांगली. आणि आपले फॉरेन स्पीकर्स वगैरे थोडे अरेंज करायचे होते. रामजी सर पण आले होते इनॉग्रेशनला, गेस्ट ऑफ ऑनर. तर असं करून केली आता अरेंजमेंट. बरेचसे आहेत सर, 200 रजिस्ट्रेशन आहेत. पण ऍक्च्युली सेशन मध्ये 130 पर्यंत असतात. 130 वगैरे 135 वगैरे लोक असतात. चांगला आहे ऑडियन्स. तुमचा आवाज थोडा कमी येतोय मला.
130 इज अ गुड ऑडियन्स म्हणलं.
येस सर, इट्स अ गुड नंबर. मॅडम पहिले तुम्हाला इंट्रोड्यूस करतील, वेलकम करतील, आणि मग तुमची स्क्रीन तुम्ही शेअर करा. आता त्यांनी त्यांची केली. Hello, Soumya sir, Bhagyalakshmi ma'am.
Yes, ma'am.
I think we should start now.
Yes, sir. Yes, ma'am. Yes. Very good morning, everyone. Warm wishes from EC Department of SIT Bhubaneswar. So now moving forward, I would like to take the privilege to introduce Dr. Madhukar Deshmukh sir for the session 8.
Hello.
Yes, sir. Madhukar Deshmukh sir, he did his in June 2000, he received Master degree of Engineering in Digital System. He received his Master of Engineering in Digital System from MNREC Allahabad. Now it is known as MNREC Allahabad. He has obtained his PhD from Aalborg University, Denmark. He receives fellowships, prestigious National Science Foundation of Israel, postdoctoral research with Professor Amir Lesham and Faculty of Engineering of Elan University, Israel. His area of research is in wireless communication, cognitive communication, and signal processing, estimation and detection, stochastic geometry tools for wireless communication, spectrum access, and wireless sensor networks. He has some important research work published in respective journals and conferences. Currently, he is also working on FSO communication for vehicular networks and vocal networks. He has nearly 20 years of teaching experience with Indian and in foreign university, along with technical work experience in Indian Air Force. So it's a great pleasure that we are having Dr. Deshmukh sir. Is a moment of appreciation and a token of love from us. It's a bouquet, flower bouquet.
Thank you,
Thank
madam.
you, sir.
Thank
Now,
you.
I request Dr. Deshmukh sir to deliver the talk.
Welcome, sir.
Regarding vehicular ad hoc network to internet.
Thank you,
Thank you.
Okay, shall I share my?
Yes, sir. Now you can share your screen.
Can you see, madam?
Yes, sir. Yes, sir. We can see your screen.
Okay. This. Okay, good morning to everybody. Today, our theme of the our this FDP was IoT and 5G. So people have understanding that this IoT is something different and 5G is something is cellular. It is a cellular network, wireless to give wireless services, broadband services. But now the communication, wireless communication is going to be more and more integrated, and with different applications and different use cases. So vehicular communication is one of the use case of wireless communication, and because earlier we could provide wireless communication with low mobility, but now we can, since larger bandwidth and bandwidth availability due to 5G and other technologies, and so it can serve for high data rate provision for high speed vehicles also. So taking into this consideration, I'm going to present a topic vehicular ad hoc networks to Internet of Vehicles. And in that also, we are doing some research in FSO communication. So that also I will touch, so that as a physical layer, we are going to use that. So, but we are doing some experiments in this, some theoretical work, but I do not know, I mean, how feasible it will be later on, but we are trying. But that will be a very, I mean, very high bandwidth solution, and very, I mean, it can support mobility, and it has more benefits than existing technologies. However, it has some issues that has to be tackled, and on that we are working. So my agenda today will be I will talk on background on V2X communication, little background on vehicular ad hoc networks, and then I will talk how we can go from what will be the problems from going from vehicular ad hoc networks to IOV, Internet of Vehicles, because Internet of Vehicles poses more challenges, and we will see what will be that challenges. Then I will be talking on OWC, that is optical wireless communication, and little on channel effects and modeling, CSI estimation, and finally how it can be used in OWC can be used in V2X communication, or you can say this for the purpose of providing Internet of Vehicles, or to enable Internet of Vehicles. So how you can use OWC, that is optical wireless communication. So these things I will talk, because optical wireless communication, that is nominally or typically known as also free space optical communication, FSO communication, had been typically used for point-to-point communication for very high data rate links, providing very high data rate links. But here, by using collimated beams, we are trying to also use it for vehicular communication to service broadband, or to enable to provide broadband data for vehicles for different purposes. So let us first understand what is vehicular communication, and then we'll go for what are the challenges, and then we can see whether we can provide it or not by using OWC. So if we see, in general, it is called an intelligent transport system, and it encompasses this traffic, internet, or you can say data communication from vehicle to vehicle, vehicle to cellular communication, that is base stations, hotspots, on the people on the road, and with terrestrial broadcast of, let us say, video broadcast, terrestrial video broadcast with satellites. So every type of communication it engulfs, and then your intelligent transport system, what we are envisaging, will be realized. So different existing technologies, can we use existing technologies for...
Excuse me, sir. Sir, may I interrupt you?
Yes, sir.
Sir, can you maximize the screen?
Yeah, sorry. Oh, is it okay?
Yes, sir. Fine.
Okay. So, so it engulfs everything. I mean, all these technologies it should use, and even vehicles should be able to communicate with satellites, your terrestrial broadcast stations, and your cellular communication base stations, and hotspots, and etc. And it should also be able to talk car to car or vehicle to vehicle and vehicle to infrastructure on road and so on. Here, one thing I want to mention at the left bottom corner, uh, the, the spectra or frequencies that can be used for these engulfing, all engulfing communication system will be from 5 gigahertz as at for Wi-Fi, 60 gigahertz cellular communication, that is now 5G communication, and IR also can be used. So at the last, I will be talking on this IR. So for time being, we will leave it here, and that is what I call OWC, optical wireless communication. So what is intelligent transport system? So what it envisages? So advanced vehicles and associated transportation infrastructure that will use, that is, are technologies belonging to, that is, your transportation or intelligent transport and communication technologies. So to have safe communication, safety, driving safety, then communication, that is, to enable that we need vehicle to vehicle communication, and that should be very, very efficient communication. Otherwise, if some sensor senses, that proximity sensor, let us say, senses that some vehicle is there nearby, and it may have, or we may lead to accident, then it has to be, the communication should be very, very efficient, and it should happen, there should not be delays. I mean, if delay will be there, then it is of no use, because vehicles are going to travel at least 150 kilometers and more than that. So it should happen in uh, very less time, that the driver should know what is happening, or what is happening around him, that complete environment he should know. So, and that should be known very very short time. So communication delays should be very less. So that is a technical challenge in vehicular communication, that is vehicle to vehicle communication. So now, if you talk about ITS, the intelligent transport system, again, because now transport has become, even in India, as a transportation is done by even government agencies, private agencies, and also in this, then if suppose we want to realize this technology, then academic research in transportation technologies and communication technologies should come together, and they should find out solutions for difficult challenges which are going to be there in intelligent transport system. Typically, mainly in India, if you see, there are more number of accident on the road than even how many people died in COVID. More people die on accident, due to accident on the road. So road safety is very important, and intelligent transport system will provide road safety, and even some infotainment, entertainment in the vehicles, and also it will manage the traffic. So in this, now we are communication people, and we have to provide wireless communication. with high data rate, minimum delays, very less delays. I mean, delay constraint is very high, in specifically in vehicle to vehicle communication. So these things are to be considered while while designing or while thinking of the architecture and of the system. Also, what are the existing technologies, communication technologies specifically, that also should be used so that, and keeping in this view, different technologies or different standards have come up, and that we will discuss on these standards and how insufficient these standards are for future development in intelligent transport system. We will be seeing that also, and then further. So this is a reference architecture of your ITS system, and that says 3 main applications of your ITS system, as we have just discussed. One is road safety, very, very important. Then traffic efficiency and traffic management. And third is your infotainment, that is the people who are actually sitting in the vehicle, they should also get actually they should be able to use entertainment applications. So internet, they should be able to connect it to the internet. They should be able to connect it to the edge, and so many other applications. So keeping in view this, so this architecture proposes there is one management system, that is management of these layers. So communication will happen in this layer. You can see here, once again, I will show you that physical layer and the transmission will happen on these different spectra by using different radio access technologies like Wi-Fi 802.15x and 2G, 3G, even 5G now. So initially it was, when this when this architecture was proposed, that time 5G was not considered. So 5G now, and not 2G, of course, it will not be considered. Then your 60 gigahertz, so that is 5G will come in that, and IR, infrared. Then so RATX, that is radio access interfaces. Then your networking protocols, because at the network layer, and transport protocols. Then session layer protocols and application layer and support. So this is a communication layer architecture. And to manage these layers, we have management information system base. So there may be cross layer management, station management at this, that is station means where this device transceivers are located. Then again application management. So we were trying to design, that means the entire interface, visual interface for, in the car, for taking the signals from different cars and creating a graphical user interface, so that the entire environment, spatial environment around its own car or particular car will be seen on this graphical user interface. So that is your application management. Car-to-car communication happens between the sensors, or you can say device-to-device communication. That also has to be managed. So these management planes are for that. And there are security aspects. So hardware security model and software security model of different particular layers should be provided by this architecture. So this is what your ITS architecture. So I need to see the time. Okay. Now, if we talk about existing proposed or existing technologies in vehicular communication, one is called as DSRC, dedicated short range communication, and further it evolved into wireless access vehicular network, that is called as wave network. So wave networks again considers that is IEEE 802.15 and IEEE 802.1609. So these standards are added together, or they work together to provide your new standard, that is wireless access vehicular network. So what are the, how this, what are the important features of DSRC are, if it is related to the spectrum dedicated to, when we talk about DSRC, the spectrum is related, dedicated specifically to vehicular communication. So DSRC technologies will work, or standards work on this dedicated spectrum, but these allocated spectrums are different in different countries. So US, that is FCC, that is of US, Federal Communication Commission, allocated 75 megahertz spectrum, and in 5.9 gigahertz band. So whereas ITC allocated 30 megahertz spectrum in 5.9 gigahertz band. So in different countries, spectrum allocated for dedicated short range communication, and actually this TSRC technologies only has communication between car to car. There is no provision of communication between car to infrastructure and all that. So it is just for communication between vehicle to vehicle communication. So, but whereas wireless access vehicular network, it is an improved version of DSRC, and it is related, these standards are related to medium access layer and also physical layer. In DSRC, they use 802.11p, and here in wireless access network, they use 802.11p as well as IEEE 1609. So that this targeted application, that is vehicular to infrastructure, also can be provided. So this wireless space wave standard specifically talks about or defines MAC and physical protocols or physical layer protocols. However, higher layers also are considered in this way. So this will be a picture vehicle to everything that is desired, and we have to have integrate, because it is not finalized yet what standard that is will come up, but people have proposed many architectures and using different technologies or radio access technologies. So this will be a picture. You can say now highways, even in India, vehicles travel at 120, 150, and sometimes more than that speeds, and to provide vehicle to vehicle communication, as I told earlier. And because it is not only highways, it is also railways, and it is also even airways and waterways. So all this communication should happen between different vehicles, vehicles on road, vehicles on rail, and vehicles on water, and vehicles in the air. So communication should happen, intercommunication should happen between these vehicles. That is expected. And but the basic thought when it started was vehicle to vehicle communication for road safety application. But now uh, vehicle can act as relay and so on. So it can provide the uh, services to the network itself as by acting as a relay and so on. So this picture you can see is uh, representative of what is going to come in future. So now current architectures, what they envisages is vehicle to vehicle communication, vehicle to infrastructure communication, and then there are three layers. So vehicle to vehicle communication will happen. The radio access technology will be different. Then vehicle to infrastructure, radio access technology will be different, and vehicle to internet through cellular base stations or other modes will happen. That is, you can say, uh, other modes. I mean, 5G or so on, WiMAX or 5G base station or other base stations. So you can see here V2V is, uh, as I told, this is for your road safety. V2V is specifically for road safety. Vehicle to base station or infrastructure is for providing internet services to the vehicle, right? And internet services may be used for different applications. That is to gather the information. That is traffic management applications or infotainment applications and so on. So you'll be clear uh, what kind of scenario will be there on this and what. So now one more thing I want to tell, that is, which I forgot. Now, as we have seen, then go back. So if this scenario appears in future, then what will be the bandwidth requirement for one vehicle? And there are multiple vehicles in very close proximity. So bandwidth requirements will be very high, and researchers envisage that even 5G will not be able to provide this bandwidth which is required for your vehicles. So as I told, again we will go back to this slide, and we can think here that V2V communication may be happening on different spectrum, so that it can have seamless communication with very Niagara delay or very small delay. Then vehicle to infrastructure, okay. Then 5G for infotainment applications and your traffic management applications and so on. This 5G may be able to provide, or you can use even WiMAX technologies. So why I am saying this? Because my proposal is using dedicated spectrum, which is a free spectrum, IR spectrum, for V2V communication, and also for vehicle to base station communication through the nodes, intermittent nodes on the road. So this I will show you later on. Now if you see, there is communication access and hello. So this CALM architecture here we provide that is, you can see here, some of these technologies, or what we can see in lighter green color. So this CAM architecture, it means communication access for land mobiles. It was initially envisaged, but now again architecture has to be changed because applications have changed and different technologies. People think that different technologies together can be used for this, because a lot of investment already has been gone into this different developing different technologies. So that may be that is one issue. Another issue is some of the requirements in vehicular communication or intelligent transport may not be provided by existing standards and existing technologies. So this architecture, in this specifically what we have to see is 3G cellular standards, 2G cellular standards that may not be now used, but instead of that 5G may be used, and some of the new standards may be added, or new radio access technologies should be added to this. So I will not discuss in detail this because I have to discuss so many things. Now, what are the radio access technologies? As we talked about DSRC, so DSRC as dedicated short range communication initially envisaged for only for this thing, like vehicle to vehicle communication basic, and it was based upon initially 802.11a and then IEEE 802.11a, then transformed or proposed a new standard 11p when we talked about wave network or wave standards. So 11p provides actually are used in DSRC, dedicated short range communication also, and now it is adopted by wave also. But wave also adopts IEEE 1609, IEEE P 1609 standard or from layer 3 to 7 OSI architecture. Layer, you know what are the layers from 3 to 7. So these are the two currently proposed. So DSRC is already there in US, and they have proposed wave. Wave is not yet, I mean, it is standards are given, but technology, it is not operating. I mean, it is not deployed yet. Wave is not yet deployed even in US. So India, nothing is deployed. If you see, we can, if we go, if anybody is traveling in car, what we do is, if you want to find out the where is your car, the location, so you use this GPS system so that we get your own location. And there are people have developed different applications based upon that, but it is not a dedicated service for vehicular communication. Okay, so in India, it is not DSRC, either DSRC nor wave, of course, is not deployed. So, of course, we have not developed standards, our own standards, but my view is, can we develop our own standards, and can we use different spectrum or dedicated for V2V communication and your V2I communication? So that was my view, and I'm going to propose some a new access technology for this intelligent transport system. So there are different wave family and different 1609, IEEE 1609, P1609 is a wave standard, and that is a new standard, and 1609.0 defines architecture that is architecture and service for multi-channel wave devices. So wave devices here we can understand is wave devices will be multi-channel, right? Because different services or the different applications will be using these multiple channels. Secondly, 1609.2 defines security services for applications and management messages, because we have to manage the messages between inter-vehicle and so on. So 1609. So this is the entire standard stack. So until 1609.12, and which describes or defines different things in this particular standards. So like 1609.4 developed in 2010, it talks about multi-channel operation of various standard message formats for DSRC applications at 5.9 gigahertz. So it is proposed by FCC. ITC also proposed this 5.9 gigahertz with different bandwidth, 30 megahertz bandwidth. So 1609.5, this is this defines communication management services between vehicle-based devices and fixed RSUs, the roadside units, that is called as roadside units, RSUs. So you can say it is not roadside units are not road to infrastructure or vehicle to infrastructure communication. Anything, please, if you want to say something. Anybody wants to say something? Okay. And so on. So this wave has a complete stack until 1609.12. So now we will talk about this time 7. Okay, still we have 50 minutes. From VANET to IOV. So how we will go from VANET to, we have seen vehicular ad hoc network, that DSRC standards and wave standards comes under vehicular ad hoc network standards. And what is, we will compare, that is between VANET and IOV. What is IOV? IOV is your Internet of Vehicles. So Internet of Vehicles now engulfs many things, that is vehicle to vehicle communication, vehicle to roadside unit communication, vehicle to pedestrian communication, vehicle to cellular base stations, vehicle to satellite communication, satellites, and so on. So this IOV will engulf everything. So what are the limitations or comparative analysis if we do of between VANET and IOV? So VANET, it supports some specific applications like safety and traffic management or traffic efficiency, and internet access is not fully available. That means you cannot do infotainment and other applications we cannot use, maybe like GPS, GPRS, all this. But here, since IOV is a business-oriented architecture, so there are opportunities for various applications. Like, of course, safety applications will be there. Traffic management applications will be there. That is, traffic management considers optimization, traffic optimization and efficiency. That is, diverting the traffic from another road to another road and giving messages and so on, which will increase the traffic efficiency, speed increase, no congestion, and so on. And infotainment. So all these three basic applications like safety, traffic management and traffic efficiency and infotainment. All these three will be provided or envisaged to be provided by internet to vehicles technologies, which will come later on or envisaged for future, whereas VANET cannot do it. So what are the collaboration capabilities? So VANET is a particular specific architecture, as we have seen in the form of wave, or you can see in the form of that DSRC, and which does not collaborate to other technologies. So IOV is envisaged to collaborate between heterogeneous networks, maybe even ZigBee and so on, different radio access technologies. Whereas now, what will be the communication type available in VANET? Yes. Hello.
No, sir. Some background noise are there, so you may continue.
Okay. Okay.
I request you to please mute all the participants.
Yeah. Now, VANET basically is designed for vehicle to vehicle, as I told, roadside, and partially vehicle to infrastructure. When we talk about infrastructure, it means base stations, cellular base stations, and so on, or maybe other that is network providers. Whereas IOV includes different type of communications: vehicle to vehicle, vehicle to roadside, vehicle to infrastructure. Vehicle to human, which is walking on the road. Vehicle to sensor networks also is envisaged in IOV. Now, can you gauge from this now here I have written a note that says that what will be the challenges to provide all this type of communication. If we want to provide vehicle to sensor network communication, vehicle to pedestrian communication, vehicle to different devices communication. So heterogeneous networks, vehicle to heterogeneous networks, these different type of communication will pose different challenges, and one of the major challenge will be bandwidth requirement. So spectrum availability and bandwidth requirement will be one of the main challenges, because some applications or some networks, they have a lot of data, but there is no delay constraint. See, bandwidth bandwidth requirement is defined by basically two things. One is amount of data, and another is QoS requirement. In that QoS requirement, delay requirement is very, very important. So in vehicular communication, since the vehicles are traveling with very high speed, and there are various type of vehicles, trains may travel at different speeds, road vehicles may travel at different speeds, and so on. If this, if you have to communicate with vehicles of different or entities having different speeds, can you think of the channel? What will be the channel condition? And what will be, if with very high speed, basically what happens is Doppler effects are dominating on the channel. And then what type of coding schemes, what type of modulation schemes, that is access mechanism is to be used, is very, very, very challenging. So some more differences we'll see. Then there is processing power and decision capabilities. So VANET has very limited processing power, data processing power, and it expects only low volume of data. Whereas IOV also will entertain the cloud-based services. So big data will be very big, because people on the road also may be able to use different applications. They may be working also, sitting in the vehicle, and they can use different applications related to and which may have volume of data will be very big, and so on. And even vehicles, I told, can be used as a network entity or network node. So vehicle may have to do various processing applications at its own level, like data mining and big data analysis and so on, which is a cloud-based services. Okay. So nextly, what is compatibility with personal devices? So VANET has limited, and IOV is supposed to have any personal device. Uh, any personal device, I mean, what we are using, like mobile phones and so on, laptops, and so many things. Scalability. VANET is non-scalable, because if you increase the number of vehicles and number of devices, then it may not be of use. It may not be able to communicate. And if it is communicating for V2V and density of vehicles increases, then it will not provide the road safety also. IOV, it is scalable. So, and because it has various access type, that is radio access technologies, connectivity, vehicles can experience connections, disconnections, as I told now, because it is not scalable, and it has very limited bandwidth and so on. But IOV, it is envisaged the vehicles will be always connected, and different applications used by different people in the vehicle itself will also be connected. So you can understand. Again, I want to point out that what will be the bandwidth requirement. So then VANET, network environment and awareness. IOV, it will have the global network awareness, as I told, cloud assisted, and cloud computing is possible, which is not possible in VANET. So these are the limitations of VANET, and Internet of Vehicles will have all these. So it will be Internet of Vehicles, we can connect anything from anywhere. It is something like this. But to enable this, there are challenges are numerous, and people, research community has started working on this very rigorously. So this is, as I told, scenario, V2H, and we have discussed all this already. So now, what is IOV detailing? So let me see the time. So I will have to go a little faster. Please bear with me. So IOV is a distributed transport fabric, because different radio access technologies heterogeneously coming together, and these technologies are expected to be managed by this IOV architecture and so on. So heterogeneous network
Excuse me, madam. Hello? Pritham?
Yes, sir.
I think sir has disconnected.
Yes, sir.
Just a minute, let me go. There is a technical error from Dr. Deshmukh's side. So he's trying to resume it as soon as possible. I request all the participants, please stay tuned. Thank you.
Sir, I have joined, sir. I have joined.
Okay, sir. Okay, sir.
So, for as I told you, that there will be very different research challenges in this, and our academic community can, some of the people can take interest in working in this. So, and different problems will be posed at different layers, access layer, physical layer, and so on. So let us see. So the IOV should make profit from different. What are the objectives? Interaction with humans, electrician drivers that we have discussed already. So 1 minute.
Sir, sorry for interrupting you. Yes, sir.
Yes,
okay.
yes. Interaction with humans. So this we have discussed. So open and flexible architecture. What are the objectives of architectural definition? Because if you want to include this much, and different heterogeneous radio access technologies and all these, then it should be architecture should be open and flexible. So because there are very different applications. So, and there should be novel management of the different layers, control and data planes. We may have software defined networks and network function virtualization. These technologies can be used, recent technologies. So accommodate a large set of business models. Architecture should accommodate large set of business models, like what we are currently we're using the GPRS, GPS technologies and so on. Allow inclusion of the current ITS and vanity systems. So currently what technology is developed, like for intelligent transport system, that is I told IEEE for DSRC and WAVE, standards. This also be included in it, and should also be compatible to IoT framework. So IoT is basically based upon sensor-based networks, and this should be also compatible to that. So this is IoV layered architecture. I think diagram is not some problem in diagram, but you can read it. I hope. So there will be 5-layered architecture. You can see here layers: business layer, application layer, artificial intelligence layer, coordination layer, and perception layer. So artificial, let us say for applications we have seen business models. We can have different business models, but our as a technical engineer or researcher, what we have to see is at the artificial intelligence layer, we have what is the cloud computing, big data analysis, and some data mining, etc. So functional, what will be the functionality? Storing, processing, analysis of data, and so on, and service management, coordination. Now here, we have to work these 2 layers mostly, and computer people, network people, they can work in artificial intelligence layer also. But of course, artificial intelligence is used in lower layers also. It is machine learning techniques. Heterogeneous networks, wave, Wi-Fi, LTE, that is LTE in terms of 5G, then unified structure transformation. Functionalities will be interoperability provisions, secure transportation of information, and so on. These will be functionalities. And perception, how to build the perception at the sensor and actuators at the vehicle level, at the station level, I mean, of the vehicles, RSUs, that is roadside units, personal devices. So we have to create an environment inside the car, spatial environment, and you can say interactional environment, everything. So this architecture should provide all this open and flexible architecture, and so on. Now, I will talk on something on, as I told you, since the bandwidth requirements are very, very high, in so electromagnetic spectrum, if you say radio frequency spectrum, lower radio frequency spectrum, in that, if you see the ability to provide the bandwidth will be less. So I talked about vehicle to vehicle, vehicle to roadside unit, and vehicle to infrastructure. These will be the main communication challenges initially. And as I told you, it will require large bandwidth. So where from we can bring in this bandwidth? So free space optical wireless communication can be a candidate solution. So how it works? So here I'm talking about the laser transmitter, which works in IR 1500 nanometer range. I'm considering. Lower infrared or higher infrared from 750 to 1500 nanometers. And it can receive, the photodetector can receive the signal. So communication is going to happen in this. But problem here is, it is not omnidirectional. Whereas the lower RF is in omnidirectional communication. So how can we use this type of communication for road communication or vehicular communication? That is the point. So we have worked on this. We can spread this beam as we have seen, as we can see, and as it goes on spreading, the diameter, it is in 3 dimensions, you can see. So the diameter of the beam can be increased, and vehicles are going to travel on the very constrained width of the road. In India, if we talk about 4-lane or 6-lane highways, I'm talking about, the width is 33 meters. So we have done some simulation work, and we have seen that for nearly 720 meters, 500 to 720 meters, it can occupy the entire road width, and we can provide, of course, it has different challenges, because if there will be vehicles behind vehicles and so on, these challenges also we can take care of by differently or adequately placing the transmitters and receivers on the vehicles. So, and we can use many different transmitters. We can use different antennas, multiple antennas for communication. So that also can be done. So we want to use this communication medium for our vehicular communication, which had been until now used for one point-to-point communication, providing very high bandwidth. So it can provide full duplex communication and so on. So we have done some studies. So what will be the OWC spectrum, that is infrared spectrum, 750 to 1500 nanometers we are going to consider. And these are the advantages. So of this, 1 minute, okay. So in different wavelengths, what are the advantages? You can see. So I have a little less time, so I will not go much into this. Okay. So 760 nanometer, this is important. So 1 millimeter or 1500 nanometers, I'm talking about 1500 nanometers to 760 nanometers. That is what we are going to see. So it has short and medium ranges in Wi-Fi and OSCC. Ultra short, short, medium, long, and communication distance. Ultra long ranges in FSOC, and they are different devices I'm talking about. Short, medium, long, and ultra long ranges in LiDAR. Then what are the advantages? So what I mean to say here, the entire, summary of this I will tell. That is, we want to use 760 nanometer to 1500 nanometer communication wavelength in IR, and at very low, that is in milliwatt power. Power requirements will be very, because power used will be very less, because otherwise IR is dangerous for health. So we have to use, and using this, we have seen, I can show you later on that we can get better range than your wave or your DSRC, which gives 300 meters of range, communication range on the road, but it is omnidirectional. Here also we can deploy the devices, as I will tell you later on how to do it, and then it can provide double range of that, at least even up to 1 kilometer. It can be. So if you think about, if there is a road of 1000 kilometers, so 1 kilometer means we will require 1000 devices or 1000 transceivers. And 1000 transceivers, these, since they are not RF based or lower RF based devices, so in the electromagnetic spectrum, radio frequency, they are not radio frequency. So devices or transceivers will be very simple, and front end, specifically front end of the receiver and transmitters will be very simple, and this will reduce your price or cost. So we can provide this communication with very less cost also. So, these are uh, how it works in terrestrial links. So that is, we have created a test bed, and my colleague Dr. Rahul Bosu has worked on this creating a test bed and so on. But now that was created for providing point-to-point link now, and we are going to use it for vehicular communication, which is very dynamic. And this dynamic scenario, how can we use? And if it is successful, it can be a new standard, our own standards, Indian standards also. So, so these are, we get sufficient SNRs. We have seen that we get sufficient SNR at the even distance of 1 kilometer, and covering entire road width. And deployment will be done differently, okay, as I told. So you can see here, we are actually mainly interested in this thing. That is, if we have 1 milliwatt, it can provide 500. So it is about ultraviolet. But if you see lesser IR, in milliwatt range, transmit power will be milliwatt range, and it can provide still 1.25 Gbps at distance of 3.5 kilometers. If we reduce the distance to 1 kilometer, it can provide even more. So, or if you can use, if you have larger SNRs, of course there will be fading and all this effect will be there. But considering this effect, it can provide 1.25 Gbps from one transmitter. So this 1.25 Gbps for one vehicle will be a large speed, you can say, or large bandwidth we can provide. So this is what we have tested, this test bed. That is reflected FSO, what we have tested it for, but it is not direct link, it is a reflected link. So these are, this is a signal to analysis of RFSO system, what we have been, because here a scenario like a reflected FSO will be there sometime, because we have to also use reflection there. So this is geometric loss what we can have when you transmit from here. So the beam is something like this, and now we want to cover our entire road by this beam. So this geometrical loss analysis we have to do. So if we see longitudinally along the road, if we put the transmitter on the road, let us say at the center of the road, then the loss or intensity of the received signal, optical signal, will be exponentially distributed along the length and Gaussian distributed along the width. Or you can say that along the width and along the height. So, taking into this into consideration, so how to do intensity calculations for this road scenario, we have considered these basic equations.
Always. Pritam, I request you please mute all the participants. Pritam. Okay, sir. Sorry, sir. Continue.
Okay. So by using this geometric loss analysis, and now since the vehicles are moving in mobility with very high speed, so and we have to, and there is no single vehicle, there are multiple vehicles. So we have to do some traffic. So we have done some traffic studies also, which I have not mentioned here in this presentation, of course. So traffic density, what is the distribution of, in India, there have been some studies on traffic analysis has been done by IIT Guwahati. And we have used also, we are using also that results to build our model, analytical model, and for this vehicular communication. And this, because this is a challenging scenario since vehicles have speed and also there are multiple vehicles. None other is because of this vehicle velocity, we have and a distribution of the vehicle density, different distribution of vehicle density, and distribution of velocity in the different traffic scenarios. So accordingly, we have to compute or calculate the average intensity of the received optical signal at the vehicle and from the vehicle. So for uplink and for downlink. So this is the non-line of sight FSO link equation. But of course, we have to do a lot of changes in it because of this velocity that we are doing. So this is how laser beam propagates and how turbulence and other interference at the receiver. Because of, you can see this car scenario. This is so because of this mirage, how this car is looking and how that without mirage, how that car is looking. So the same thing happens here because of mirage and this scintillation, that is called as scintillation. So that are the channel losses. As in RF radio frequency, we have fading, different fading environments. Similarly, here also this fading happens here. So that we have to also taken into consideration. And there are different models for channel models for this, and we use the frequency. Different distributions for building the model. So these are different attenuation at different frequencies. So this is also the graph for turbulence. Okay. Okay. So there are so basically we are interested in that is received intensity of the vehicle and from the vehicle at the fixed node unit at the roadside or on the road. So to model this, the refractive index and so many parameters, scintillation, due to scintillation and due to this perturbations. So we have to consider different parameters that we have done. So so channel fading will be, as I told, because of all these reasons, there will be channel fading, and we have done some of the work even experimentally, and we have some results, but not complete. So what different models we are going to use for different conditions. So because there will be different conditions at the same time, available at the same time, and using these models, so mixing these different distributions of channel of the intensity of the channel, So in different conditions, and finally building the model will be a very challenging, and testing this model with your experimental setup is also very challenging. And of course, finally, we have different vehicles at the signal processing level, how to do it, that access, handling the access, handling the dealing with handover, and so on. These things also will be there, of course. So we have done some work, and these are something non-related thing. I think I forgot to this. So how we can estimate the channel, because channel estimation is one important part of the uh, reception of the signal. So that we have done. Here I cannot go into more details. So channel state information, the channel condition H will be I by attenuation, and that is uh, theoretically computed as, but in different condition as exponential to X scintillation. So that is X is perturbation due to scintillation and other reasons. Uh, so finally, what will happen to your refractive index? So your I is your received field intensity in the turbulent media, and I attenuation is received intensity in free space without turbulence. So what turbulence will be there on the road? So this we have to again model for our model, that we have. This is without. This is for only single link. In reflected link actually model. So finally we have come up with this, but here this model also for us, this is also will change. We have done some work on this, but finally it is going to change also. So what is the distribution or density of your H or channel that we have to finally compute, and from that we have to compute the SNR at the receiver, and from that we can compute the capacity availability at the receiver, and what will be the sum capacity available for different vehicles. That is again one challenging. There we have to consider the traffic density models, and so on. So that is very challenging work. So these are calculations have been done, but here it is for only single link. We have calculated this. See this. This is very important. Coherence time. So we can calculate coherence time and to 6.66 millisecond, which will be again a challenging task to provide the communication with this. So channel will be changing within after 6.6 milliseconds, 66 milliseconds. That is what coherence time tells you. So whatever we have to do is we have to do within this.
उसमें मीटिंग चल रही है, इस पे FDP चला रखी है.
So this parameter will be very, very important in consideration with, or in context with, providing very less communication with very less delays. So here, that is, I will just show you the model. This is just general scenario. This will be your width of the road, as I told, and in Indian road highways, for 6-lane highways, I am considering not on the cities, road in the cities. I am considering the communication at highways. Okay, so providing broadband communication at highways. So we have presently 33 meters wide highways that we have taken it from ISO standards for roads. This you can see here. So again, I told us this will be scenario, and we can deploy posts maybe, or there will be dedicated posts we can have on the road. In the that in the middle side, that is divider. On the divider, we are proposing the lamp posts. Sorry, not lamp post. I mean these RSUs, roadside units, and they will provide actually the downlink and uplink communication with having some fiber optic backhaul or maybe optical link backhaul. So as we have discussed this, so we have tried to have this. I mean, this is at the divider. This is a post where your transmitter will be located. Transmitter and receiver both, of course, will be located in the middle of the road. That is in the divider with post or height or mast of height, some typical height that we have to. That calculations we have done, and you can see here this 33 meters width of this beam can be achieved starting from somewhere where from here to 700 meters of distance sufficient intensity which will give you the required desired SNR or SINR, you can say. So from here to here, some of the vehicles maybe you can use this communication, but all of the vehicles may not be able to use since it does not cover 33 meters. So from here it starts covering 33 meters and it goes up to finally 700 meters. So at least 700 meters. If we increase little power, then 1.5 milliwatts, then it can to 2 milliwatts, it can go up to 2 kilometers. So we have this simulated results also in this. So this up from 33 meters, you can see here, from 33 meters, the width of the beam starts 33. So when width of the beam is 33 meters, then all the vehicles on the road will be covered. Those who are not covered, we are going to arrange next transmitter at the behind, such that these vehicles which are not covered by this beam will also be covered by another beam. So handover should happen here. Handover should start happen at here. So handing over will be there. So handing over from this wavelength to another wavelength will happen from here to here. And since we are going to use the spectrum is very broad, we can use different wavelengths, 2 to 3 wavelengths, and there will not be problem of handover. Okay, so there are some results, simulated results we have got. So how much beam radius and achieved power, for example. So that can be. So it is in general, if frequency is given, then what will be minimal detectable power required minimum detectable power. So it is in nanowatts, you can see here. So according to that, we have done this modeling, and
Sir, is there any problem? Deshmukh sir. Hello, Deshmukh sir.
Hello, Soumya. I think there is some problem at his end. Please try to call on his mobile.
Yeah.
Hello.
Yes, sir.
Yes, just there was some break again in the network.
Yes, sir.
So we have discussed. Can you see my PPT?
Yes, sir. Yes, sir. Just maximize it.
Yeah, so we have some update, we have put some equations into it, and we have basic equations, governing equations regarding this intensity received at how beam propagation will happen at and what will be the power received in at different distances. So here, first graph we can see here that tells you that beam, 1 minute. Here, beam propagation. So 700 meters at the, you can see it can go, and your received power will be sufficient enough, this much at 700 meters, so that we can detect the signal successfully at the receiver. So these are some to understand how to model or what will be the challenges in modeling, that we have done simulations, and then will be of course able to. So we have typically 671.4 meter, approximately 7, but if you add the 1.5 milliwatt power, so if I increase power, it can go up to 1 kilometer, and safe power is even 10 milliwatts. Safe power is 10 milliwatt. Safe transmit power is 10 milliwatt. So it should be little less than 10 milliwatt because it is higher propagation. So we can think of it can be you can think 1.5, even 5 milliwatt also we can go, so that distance will be increased. So we will be doing all this modeling, and then finally we will be checking it experimentally whether it happens or not. But there is a lot of work, and it is a big project. So this is just, we have initialized the project and we have some results. So that I'm going to. So, but this is very, this will be very important enabler for IOV. Challenge or challenges, especially bandwidth challenge for IOV, that is the Internet of Vehicles in future, which includes also IoT and your sensor networks and cloud computing and so on. So I suppose I have finished, and there are still some 1 minute is there. So I am very thankful for your attention and giving me opportunity to present in this August gathering of researchers and academicians. Thank you very much.
Thank you very much, sir, for such a nice and wonderful session. So
Yeah,
there are
if any
questions.
please.
So there are some questions and chat box.
Yeah. Can I see?
Yes, sir.
The box was here. Security chat. Okay. Uh, how can we reduce delay with the constraint of vehicular speeds, dynamic topology, and channel bandwidth? Yeah, of course, because this is very, very challenging. That is why now, see, your the propagation of the your signal propagation. So there are many questions I go. So what question somebody was. Okay, I will take the first question. How VANET avoids accident and reduces resource usage? Actually, in VANET, there is a device-to-device communication from one car to another car. That is vehicle-to-vehicle communication. And if one car has complete knowledge of how many cars are there around it, so if it is not, if some other car or vehicle is not in the safe distance, so if it is not in the safe distance, then the driver will get the signal or warning, and even speed warning and so on. So to provide this knowledge to the driver, we require very delay constrained communication between the cars. So that is why it is very, very important. And here constraint of delay is very, very important. So no, I am not working in actually network layer. So do we have, question is, do you have good routing protocols for VANETs which can handle high mobility vehicles and high dynamic topology? I don't think, because scenario is going to change totally, because currently I am also working in some 6G. So, but in access mechanism, that is medium access, and there these 5G, even 5G protocols or algorithms are not sufficient enough in this scenario, in 6G scenario. So we need to develop the routing protocols, and because see, as access mechanism changes, even it will affect also routing protocols and all that. All protocol stacks will be affected, and because there is a lot of dynamic environment, they will be. So there is also, I mean, this is also a challenge, and people can work in this area also, because it is very highly dynamic. Existing routing protocols will not be sufficient. That is, I'm damn sure about this. How can we reduce delay? Okay, reduce delay with the constraint, because we have to provide. See, reducing delay, it means complete information we have to send to the another vehicle. To send the complete information, we need with less delay. So we need a small packet size. Small packet size can be spread, or information can be spread over the bandwidth also. You can understand that. And that way we can also reduce the delay. Because I have, let us say, 10 MB of information from one vehicle to another, to be transmitted to one vehicle to another. Then this 10 MB can be spread over the bandwidth. So it means for that vehicle, we have to provide large bandwidth. That is why I am talking that we need larger bandwidth, which cannot be provided by VANET, existing technologies. And that is why we are considering this even IR. And when this dynamicity of the topology and these networks, or heterogeneity of the networks and so on, this dynamicity increases, then really, and your vehicle speed increases, because of that dynamicity increases. Heterogeneity of the networks also increases dynamicity, and all this will affect your delay. So it means we have to provide more bandwidth. It turns finally into channel bandwidth, and that will be done by my last solution, that is you are using IR dedicatedly. Yeah, original protocols can be also improved, or there can be some cross-layer protocols also can be improved, but keeping in view with all this dynamicity in this environment. So I don't have much knowledge in security and privacy. So I think Vandana madam may be able to answer this. Vandana madam, can you please answer this thing, because I have not worked on this security
Yes,
aspect.
yes, sir. What was the question?
Question is how we can reduce delay with the constraint. Sorry. One minute. How security can be achieved as different companies may violate the driver privacy.
Yeah, actually, the answer I would like to give for this question is like, uh, uh, different scenarios in which the violation can be done are being considered, and many researchers are working on that to provide securities accordingly. There are many people working. Sir is not working in security area, but still we can answer like this ki there are different security algorithms are already designed there, they are already in function, but still with autonomous driving vehicles or different vanets, they are being tested, and people are working on that. I also don't have exact idea which security protocols are there, but yes, we can find out information about that, but right now we don't have any
What I understand is because security mechanisms are designed for particular network environment.
yes, sir.
And since in IOV, we have heterogeneous networks coming together. So how to handle the heterogeneity in context to security and privacy, this will be a challenging task. And again, people can work in this, in security. I did not understand the last question, that is how to perform validation.
Sir, for this, may I say something?
Yeah, please.
Yes, there are different optimization algorithms are there. So recently we attended a course which was conducted by one university from IIT, and then in that they have taken a lot of optimization algorithms. So for validation purpose, we can apply particular optimization algorithm, and then we can see the performance, and we can compare the performance results with previous or existing technologies, and then validation is done. I hope I have answered it properly.
But actually, I understood this question differently,
Okay.
So, because we are building the theoretical model in context to this OWC, optical wireless communication, applied to VANET or applied to vehicular communication. So, for that we are building the model. Of course, we have not completed it, or there is going on work. Analytical work I have not shown also, because I cannot show it now here. It is half cooked. Then I was thinking that this in this context, validation will be either two ways: simulated validation or experimental validation of your theoretical model. So this also is called as validation, but I think I don't know in what context the question is asked. So I think I have these questions are finished here. No, there are many questions. Oh, 1 minute. When it so see, I am not working on VANET, but MATLAB, I will tell you, MATLAB will be a best tool. You can use Python instead of MATLAB, the more dynamic environment. But even we use for this, but there will be no. We can use MATLAB basically. I do not know any other simulation tools are there for VANET, because we are doing it at access layer. There are at network layer, there are different tools, NS1, NS2, NS3, and so on. But Python or MATLAB will be better. MATLAB may have even the toolbox for VANET, possibly. I think.
Yes, sir.
Will be there.
Yes, sir, it is there. Yeah, in Python also, or different machine learning, like algorithms in Python, it is also available over there.
See, machine learning is a tool.
Yes, sir.
It is statistical.
By using Python, we can do it.
See, let me tell something about this. Machine learning algorithms are what? Actually, they are the statistical tool which recur, which are implemented recurringly again and again for learning purpose. When we learn, and then this learned knowledge we apply to the new situation. So, specifically in wireless communication, deep learning is nowadays used at different layers, even allocation, let us say resource allocation. For resource allocation, we are using. So, IoT gateways also possible. Machine learning algorithms can be used. Yes, but I don't think machine learning will be, CNN will be required. I think deep learning networks will be required. So simple machine learning will not do.
Yes, sir. Deep learning and convolutional neural networks. There is lot of work in that. So, lot of researchers can take insights from this, and they can.
There is very interesting question here. So, can we term V2V as vehicle cloud? Yes, it is going to become vehicle cloud only, because vehicles also will be used like your let us say we have a base station, and there are various base stations and communication centers. A lot of processing capabilities are there, right? So your vehicles also will become clouds in future, and they will also provide the communication services to other vehicles and other infrastructure, even roadside infrastructure, etc. So that is actually the vision. That is the vision. But currently, if you say it is not, currently even DSRC or wave technology cannot do this, because they have bandwidth restrictions and even mobility restrictions, spectrum restriction, even frequency spectrum which is used, 5.9 gigahertz, is also insufficient to provide this or enable this vehicle as a cloud. Okay, I don't think there are much. Okay, thank you, madam. Thank you, sir.
Thank you, sir, for wonderful sessions with experiments and experimental results. So it was very nice.
Yeah, we could not do much actually, but we are doing.
Yeah, we could get some insights about how it is, how research is.
So IOV is the future.
Yes, sir. Very nice session. Samma sir, Bhagyalakshmi ma'am.
Yes, ma'am. Thank you, sir, for your wisdom and excellent presentation. We are really enlightened with your knowledge and presence. In this session, we came to know about different typical cases of intelligent transport system and its applications and services, and the details about the ITA station references, architecture, and the pictures you have shown, how the vectors has been communicated to everything, the communication access to land mobiles, and how FSO works and its link constraints and geometric loss analysis. So you show us how you have been compatible with the devices from VANET to IOV, and what are the main objectives of IOV and the different layer architecture of IOV. So, sir, once again, thank you very much. I deeply appreciate the wonderful and informative presentation you made at this session. Thank you, sir.
Thank you very much, ma'am. Vandana, madam.
Yes, sir.
Okay, I will talk to you on phone later on. Okay. So this thing.
Yes,
So
sir.
I'm very thankful for giving this opportunity. Actually, we could go in much details of this, but I could not go because of restriction of time, 1.5 hours, and to discuss the things very in detail requires a lot of time.
Yes, sir. Yes, sir. I understand. Thank you very much for your efforts, sir. Thank
But
you.
I think researchers and academicians, they got idea that everything, all whatever algorithms, protocols we produced earlier have to be improved, and there is a scope for research in that.
Yes, sir.
Yeah.
Thank you. Thank you, sir. Dear participants, I request we'll start our next session before at 2. So you all are requested to join before 2 p.m. today because our speaker is from Thailand. So I request every participant to join before 2 p.m. today.
Thank you so much, sir. Thank you, madam.
Thank you, madam.
Thank you very much.
I request Pritam to close the Zoom window.
So can I leave, sir?
Yes, sir. Yes, sir. Yes, sir.
Thank you.
Thank you.
Thank you, madam.
Thank you, sir. Thank you very much.
Good afternoon, Bandana ma'am. Chapel sir has joined.
Yes, yes. I have talked to him.
Yeah.
He has joined. Yeah. We talked and he has tried sharing his screen as well. So everything is fine. We can start within 2 minutes. Hello, Bhaki Lakshmi madam.
Yes, ma'am.
I think we should start.
Yes, ma'am.
Soma sir.
Yes, ma'am. Yes.
Yes, yes. Should we start?
Yes, sir.
Yes, madam, please.
Very good afternoon to all the participants and the speakers. Welcome back to the post-lunch session of third day of our program. It's a great pleasure for me to introduce our speaker today for session, 9. Dr. Chapel Camille. He is working as an associate professor, School of Information Technology, Ma Falun University, Chiang Rai, Thailand. He will deliver on the topic of IoT for melon farms in Thailand, system design and challenges. Dr. Cameron obtained his PhD in wireless communication Center for Tele-Infrastructure, CTIF, Aalborg University, Aalborg, Denmark. He did his M engineering in electrical engineering, the City College of Newark, Newark, USA. He did his master in science in laser technology and photonics, Suranari University of Technology, Nakhon Ratchasima, Thailand. He completed his BTech in telecommunication engineering from Suranari University of Technology, Nakhon Ratchasima, Thailand. His area of interest includes quality of service, quality of resilience, reliability analysis, image and video processing, and regarding the next generation networks and the wireless sensor networks and IoT application. May I request you, sir, with a virtual bouquet, sir, please. Now, I request Dr. Camille, sir, to deliver the talk. Sir, please.
I don't know if you can hear me clearly. Thank you so much for the introduction. And
thank you.
Good afternoon. Yes, thank you. Good afternoon, everyone. Good afternoon, all the committees, and thanks, Professor Vandana, for inviting me to the event. First, let me share my presentation.
Welcome, Chapel.
Thank you. Yes, so my talk today is going to be about the IoT application for the melon farm in Thailand. I'm going to talk specifically for the some of the system design and then also the challenges. So the main outline is going to be about the 5G and the IoT, and then I'm going to talk about the farm challenges and also the IoT application that designed for the melon farm. And last is going to be the solution of the design and then the benefit. So that is going to be the main topic for my talk today. So first, let's start with the IoT. I think everyone here understand about what is Internet of Things, what is IoT. Basically, there are many definitions you can refer to the IoT. Like, if you look at the keyword here, any device, anybody, anywhere, any business, any network, and anytime. Whatever things could communicate or link together by using the internet technology. And some people may think about some of the things, network that can only be connected together and not really use the internet. That kind of application also considered to be one of the IoT application if it used the IoT protocol to exchange the information between the local server and also with the device. That could be another kind of the Internet of Things. So things can be anything. And if you are online and you can connect it anytime you want. So there are many definitions actually regarding the IoT technology today. So why we are going to look at the IoT, or we need to understand the IoT? I think most of you already know that now more than a billion of people connect to the internet. And also we have so many application, for example, mobile application available for us to download and then use it nowadays with many smart devices like a smartwatch and some other controlling application like smart remote and smart television. And if you look at the picture here, you can see that from the trend, smart home, number one, and then smart personal devices, like number two, whatever things that close to our daily life, like we are living at home, living in the office, we actually need this kind of smart devices so that we could take some benefit out of these devices more than what we are using normally. Like a smartwatch, we can use this to track or to alert or to do something besides telling the time. And you can, if you look here at the bottom, we also have the smart farming. During that time, maybe 2014 to 17, we don't really have much, smart farming technology. Even in Thailand, we don't really, use technology for the small and then medium-sized farm. But today, in the year of 2020, more of the young generation, they call themselves like young smart farmer, more graduate student, they decide not to work, in the company. When they came back to their hometown, most of the Thai population, their career is the agriculture. So they try to adapt their knowledge, like building the website to promote the farm, or even apply some of the IoT technology to use within the farm for some process. And today I'm going to focus on the smart melon farm. So why do we need the IoT? And if you look at the process here from the beginning, the connecting the device or sensors. So we may connect some sensors to some hardware so that it became a smart device. And then after we connect with the sensors, the sensor can sense the information or collect the data from the device. And then the data can be recorded for an analysis. So we can do the data analytics if we have a lot of data from many sensors. And then that data can be used to take some actions or to make a decision, or it can be applied, based on that information. You can get some benefit, or you can make a final decision to make, things better. So this could be like the flow and then the benefit that we could receive from the IoT application. So back to the question again, why IoT? The main purpose, the main benefit may be regarding, how you are going to use that information from the sensors, or the information that you can collect from the sensors, or from connecting things, to work together. it depends on your purpose. So that is make the IoT, important for different application. Okay. Okay. Let's look at the IoT components. The list that I put here is like some of the basic components that we can form the IoT, basic IoT application. We're starting with the devices. We could have the any device that connect to the sensor, and it can become some smart devices. And then definitely we're going to have a sensing device, or the sensors, or the actuators, another kind of sensor that change um, uh, the physical quantity into the electrical quantities. And then we also have the connectivities, like we can make use of the personal area network or the local area network by using the Wi-Fi connectivities, or we can use the Bluetooth for personal area network, or we can use make use of the Zigbee, or we can use the wired connection like serial communication, or Modbus, one of another serial communication, like if we connect sensors together with the controller node. And the gateway, definitely we normally use to connect to the internet. We can call like the internet gateway. And if we want to connect to the other network, definitely we cannot deny the internet as one part of the IoT component system. And if we are going to upload our information to the server, to the cloud, we definitely need the cloud server. All of this could be considered as the basic component if you are going to build the IoT system. Oops, I need to create a drawing first. And the picture here showing you the basic, you can call it the fundamental IoT architectures. Actually, there are many, how can I say, many architecture definition that are defined by many organizations and many companies. But we could break it up to 4 main part, like this one. And we have the device, or the device that connect to the sensors. And these kind of sensors may be control or collect the information by using the controller or microprocessors. And before going to the internet or to the cloud server, we couldn't connect to the gateway. But as I mentioned earlier, we couldn't make it connect to the local server, local server. And this could be another kind of network that we can make use of the IoT architectures. Instead of sending everything to the cloud, we can have our own local server, and then we can still get the benefit of the IoT application. And within here, we can, you can perform, different kind of the fog computing, edge computing, if we are using the 5G technology in the near future. Let me clear this drawing again. Okay. Okay. And then, after we're looking at some of the concept of the IoT, let's talk a little bit more about the 5G key features. Actually, there are many commitments for the 5G technology, but the key feature here that could, drive the IoT technology more and far more better, which is about the connections that the 5G aimed at. It could support up to 1 million devices, in the area of the square kilometers. And then about the end-to-end latencies or delay, between end device to another end device, they could make it less, up to 1 millisecond. And about also the speed, of the data transferring, it could support up to 10 gigabit per second. So imagine you uploading, your information to the cloud. It just feel like you uploading it or doing things with your thumb drive or USB drive, at your local computer. If you going to have this kind of 10 gigabit per second speed for the 5G. So all of these key features of technology, that will come with the 5G technology definitely is going to support a different kind of IoT application. Okay. So let's look at another factors, that normally drive the IoT technology, starting from the year 2000. You can see that before we are using like a tag and an ID, in this technology, and then later on we adapted to the security, surveillance, transportation, logistic application, and then we aim to use the technology to locate things and people. And in the near future, we're trying to remotely control and monitor, things. So definitely, this 5G and then the trend of the IoT application adoption, will be supported of the needs, that saying here as the trend. And if we are looking at the IoT application, there are many actually. You can imagine from the figure here, in transport or logistics, they can use it to for like different kind of application that related to the logistic, mainly about the tracking, and you can use it for the smart grid, for the utilities and smart city application like parking, waste management, and smart building, smart office, smart people. You can use this to track your activities, track your health condition, for the senior or elderly. In industrial, also apply a lot of IoT application to improve the performance of the process monitoring and control, and also to maintain the machine and to check if the machine is working, normally by using different kind of sensors to check the condition of the machine. And for the environment, we can also apply the different kind of sensors and different kind of IoT application to monitor, the environment, and then send up some warning, some information so that we can know more about the environment. And definitely, last but not least, in agriculture, we can actually benefit more if we use the IoT, more of the IoT to monitor and then control things, within the farm. And after we, looking at the IoT concept and application and what we can do with the IoT, and also what we can do more when the 5G, come in the near future. we still have some challenges in the, in applying the IoT. Like the first one, I think most of you, if you're working in the IoT field, you should know that choosing the right equipment is quite difficult. What equipment, you should use for this application, because there are many players, many vendors, and then also many port, many capacity, for that equipment. So you need to choose the equipment for your application. And then you have to think about the connectivities. If you are going to connect it locally, or if you want to use it wherever you want, so you need to connect to the internet. And then the next challenge is going to be the power supply. Now, if you are going to use what is going to be the power supply for your hardware or equipment. And mainly in agriculture, most of the farmer that I'm dealing with is going to need some system that could help with the fertilization, and then also, giving the water, into the farm. So this could be considered as the two main problem that need some help, for the farmer. And another challenge is the how to transfer the knowledge to the farmer after we, have the system for them, if they are interested to use it at the beginning, or if they can use it, after we give them something. So this is one of the challenges that we face, when we work with the farmer, especially in Thailand. And then the last point, is about the investment and then the cost. Even though before we conduct the experiment by using some funding from the research funding, but if you are going to maintain the system so that the farmer can use that system, in the long term. So we need to think about the money and the cost and investments. If some other farmer need also the same system, how much they need to invest, and is it worth, doing this? So the price need not to be, too expensive, and it have to be some amount that we can also, can also build, use it to build the system and maintain the server for the farmer. So let's look at the, some of the challenges, of these challenges one by one. Okay. So first one, choosing the right IoT platform or IoT equipment sometimes is very complicated. If you search today, there are many, open source, IoT platform, and also commercial IoT platform. You can build your own IoT platform also. So, choosing the right platform and also equipment is one of the challenges, but it's not but if you look into it carefully, you can try, different platform, if you find that which one is work for you, easy for you to apply, depending on how much time you have, in order to build the system. So you can use that information to make a decision. And another challenge is I call it the technology convergence. So in this technology convergence, they talk about the greenfields and also the brownfields deployment. You already know that the brownfield deployment is when you have the old infrastructure. If you have the machines or the technology that you already have within the farm, how you can, how can you add the new technology in, and then have it used, together with the old technology. How can you do that, to put it together so that it can work, well with each other. But if you have like a greenfield deployment, that will be no problem because you're going to develop, everything, for the farm. But if you need to use some of the hardware or existing technology or device, so you need to think about how to put it together. Okay. So choosing the sensors is one of the challenges, if you want something, durabilities, if it can use within one specific environment condition. In some case, you may want some kind of water resistant sensors that can use, with the outdoor farm or outdoor environment. And sometimes you may want to have like a high sensitivity sensors, or you want high accuracy, but definitely the money, the price will be high too. Versatilities, and the sensors, sometimes there's some kind of sensor that can work well with the quick changing environment, but also the price will be high. And last but not least, the power consumption, for that sensor. If we want to use that sensor with the solar cells, so we may need to think about the sleep mode and fast wake-up mode if we can control the sensors so that it will not consume any energy, during the charging mode of the solar cells. And then if there's some information coming, for the sensors, it can do the fast backup and then send us, trigger that information and then collect it into the system. And the important thing is the cost here. So the system that I'm going to talk about, that I choose the quality and the price that in between, it's not the experimental sensors, but it's like in between experimental and then the commercial. So it's not too expensive, but it can still use, for like more than 6 months, in operation for our sensor in this experiment. About the connectivities, and this one is quite important because sometimes if you want to apply the technology for some farm that has no internet access. So if it has the internet access, you can connect it to the Wi-Fi very easily. But if you don't have the internet access, maybe you may think of the mobile data, like from the mobile network, by buying the internet SIMs, for using with your IoT devices. And the power supply also one of the main challenges, So it will be very nice if you can use the electrical, from the household, in case that the farm is very far away from the source of the electrical power. Maybe you need to use the solar cells, and in this case, you may have to design, how many watt, you may need in order to fully support your IoT application. And one of the important things that you may, have to look at is the if the device support the, AC, the DC current, because you may need to find some kind of adapter in order to link between an AC and DC devices for your application. And the last challenges, not only the last one, you may have to look at the securities. If in the future you may need to connect to another network or to the world. So if your farm or technology is getting famous, you may be like one of the target for the cyber criminal. So the security need to be one of the factors that you need to look at. And how are you going to deal with the communication protocol? As we know now, we have like MQTT, one of the IoT protocol. You have CoAP. You're working with the HTTP, and then also the some other protocol. Some of it may not really in the standard communication protocol, but we may need to apply it, maybe link between different communication protocol together. That could be one of the challenges. And the last one is quite important, how you can get some inside information from your collected data. And this one is quite important, especially when you have to work with the sensor in agriculture. So if you can get some information, from the sensor, it could help, a lot of things. It could help, blinking, a lot of innovation, from the information that you can collect. So now let's talk about the main experiment that I want to talk today. So in my slides, based on my experience from my research only. So I did not put any equation or algorithm within here. I just want to share you about the challenges and then also the system design. I think it is one of the interesting factors and very important point. I can show you later for the next slide. Why I think it is very important. So the farm that I'm working at is the melon farm. So this farm is, they want to produce a premium grade melon in the north of Thailand. I will show you the picture later. So they want to be the one that produce like a very, tasty melon, and they actually can do that. But the main problem that they face, during that moment is these two. The first one is the melon disease. It can be caused from many things, from the environment, from the the insects, and from the different kind of fungus. But another challenges is about the how to put the right quantity of the fertilizers, to serve the melon during each period, from like the first 45 days when you start planting the melon, how can you put the right fertilizers, to serve that kind of melon. And then the next 45 days, if you want to change the fertilizer formula, how can you do that? And how can you build some kind of system that can help with this fertilization? And another main workload is how to, provide the water, really effectively. Because if you are working with like more than 10 melon farm, you can think of how many labor work need to put into this one in order to serve your daily activities within the farm. If you have like 10 farm, 10 melon plant, and then the melon need like maybe at least 5 5 feeding waters, per days, per plant, and how many times that you may have to spend, for the irrigation. So this is one of the main problem to reduce the workload and then also to solve the disease. We may not solve this one, much by using the IoT application this time, but we are focusing on these two, fertilization and irrigation. Okay, so this slide showing you the basic sensors that we start using within the farm. The first one is the temperature and humidity sensors for the air, and then the light sensors, for the air also. And we also have the soil humidity sensors, to put and to measure the humidity, within the soil. Actually, there are many more sensors that you can apply, for different agriculture application. And we have a different controller that you can apply, but for our experiment, we use the microcontroller, especially by the specific company. It's called the ESP32, which has the developed version of the Node and CU. If you are working in this field, we can make use of the Raspberry Pi if you want, but this one is quite a good solution that we can apply it for many IoT applications here. And then one important thing is the solenoid valve or electronic valve that we use within the farm to automatically, replace the manual valve so that we can control, how to feed the fertilizer and how to feed the water into the plant by using this electronic valve. And this slide showing you the basic architecture, connection architecture for the smart farming IoT system. We have the sensor node here. We can put it within the farm, for example, and it can connect to the controller by using the wireless technology, or you can connect it by using the LoRa, video communication, and the controller can communicate to the cloud server by using the HTTP or the MQTT protocol. Also, you can use the mobile phone, to look at the dashboard application from the server, and all the controlling that normally is controlled by the people, like using the manual valve. We're going to replace it with the electronic valve, for the irrigation and then fertilization also. So this is the pictures of the farm that we are, working with, one of the melon farm. And if you look at here from the figure here, you can see that normally the labor or the farmer have to mix the fertilizers, and then put it into this basket. And then they use the venturi tube, if they want to feed some fertilizer, they just let the water flow, into the upper tube here, and then it's going to cause some kind of vacuum condition, and then to feed the fertilizer that is within this basket into the tube, and then go into the farm, the melon farm here. Or if you just want to to put the water, without the fertilizer, you can turn off this valve and then also turn off this valve to protect the water, flowing backward here. And then only the water can go, into the melon farm. So you have like a two-way. The upper one is when you want to to give the fertilizer into the melon farms by using something like the ventilator that you are seeing here. And then if you want to put only the water into the plant, you can use the second tube here. Or you can use the upper tube, without the fertilizer here. It's up to you. And you can use both way. So this is the previous system that the farm normally work for the melon farm. So actually there are many evolution. This is the when we design to work with the traditional way. You can see that you can see from this figure we have like two parallel system. The first one at the front is the old system. So in case when there is no electric power, and you can like go back and use your traditional system. And then also we have another new system in the back. You can see here we have like electronic valve 1, 2, and then also 3 at the bottom here. And actually we also having the machine. We also build a controller that can mix different formula of the fertilizer here. Normally the melon is one of the kind that need to take care, a lot, when you do the melon farm, like the first 45 days, you may need another kind of treatment. And then after that, you may need a different kind of treatment, and they need different kind of fertilizing formula. So we have like 6 container that farmer can put 6 different recipe that they can, mix any of the formula together and then fit into the melon farm to serve a different period of melon that need maybe different kind of fertilizers. Not by, they are not looking at the easy quantities, like we normally do. But what we are going to focus is here. This is the first system that we do. We just duplicate, another system, but we use the electronic valve instead of the manual valve here for the when we first applying the technology, for the melon farm. And this is the pictures of the first prototype, and then the second prototype, of the PCB board. And but basically we improve. We have many versions in between. But the one that I'm going to talk about is this one, the design system for the tube here. So as you can see from the figure, before we just duplicate, M is like this is the normal system, and this is the electronic system that we can use the application to control the valve. So we just have to duplicate the system exactly like what we did, what we have for the normal system. In case that we don't have electricity, the farmer can use the old one. So we have 3 electronic valve here, and together with the venturi here. So this is the first design system. But if you look carefully, what we can do here for the, sorry. I'm sorry, I didn't change the number. This has to be this one first. Sorry for my mistake. I put the second design after. So later on, we just change it. Now we cut this one out, the electronic valve at the bottom, and then we can only have like two electronic valve. The reason that we have two valve because when we want to let the water flow this way, we just have to open this valve first and then open this valve, as the second one, so the water can flow easily. When we want to turn off, we have to turn off this one first and turn off this one later so that we can control the water really effectively. But the reason that we cut this one out because we can, if we want to feed only the water, we can use by, sending it to this way. But this one will have no fertilizers, for the venturi container here. So in this case, if we don't really command, the motor to pump the fertilizer into the tank, it can use to feed the water. So we don't need the bottom part of our first design here. So we have left this one as the second design. But we can still have this one, in case we don't have electricity. But yeah, this is the second design. But I can tell you, actually, we don't really need this one later on. I can tell you why. I can tell you later why. So that is the second design. And this is the third design, actually, the final design that I want to show you here. You can see that from the second design, we still have two electronic valves. But for the final design, we just remove this one, but we use the check valve instead. The check valve here. The check valve, its function is to prevent the water to go back this way, and this way is going to the melon farm. So we actually can control everything by using one valve. We didn't think about it at the beginning. So if you want to feed only the water, we just don't need to put the fertilizer here. If you want to put some fertilizers, we just take in the fertilizers and then open the valve, and then the water normally flow this way. So we can just use only one valve actually, and then we have like a check valve to replace the second one. So we don't need to worry about turn this one first, turn this one later when we want to have the water flowing this way, or we have to close this one first and close this one later when we want to prevent the water flowing back this way. So we can just use the check valve, which is it costs only 50 baht or maybe less than 100 baht. But this electronic valve is cost like 1,000, more than 1,000 something. If you use a good quality, maybe 2,000 something. Comparing to this one, like more than 100 times, more expensive. So this is the final version, that we can make use, when we redesign things, So we save a lot of equipment, save a lot of money, actually, and then we reduce the system, from almost identical to the manual one to this one. For the final design. And the benefit is actually you can optimize, the algorithm that you can put into your microcontroller, so to have it work better. But importantly, you can save a lot of equipment. You can reduce less of the hardware, and then it's easy to manage. And also, finally, you save a lot of money, save a lot of cost. And another benefit I want to show you here is that if you look at the picture on on your left here, and this one is human. Everything is controlled manually. This one with our IoT system, with the machine. But you can see here the density of the leaf here, and then also if you look at here the quality of the plant, and this one is you can quite clearly see that this one is much more better. And if you look here above the picture here, when it's very very strange that they found out that the farm that they use human, normal labor to control, giving the fertilizers and also water. The yield of the plant or production yield is less than 80%. But with the machine, more than 90%, yield can be achieved, from the farm that use the system, but you still need to have someone, checking the system from time to time, but not too much like what you have, the farm that the plant that normally controlled by the human. So this plant, basically, we have no problem about the cracking of the melon. The cracking of the melon is can be caused by many things, like lack of fertilization, or maybe too much, or maybe too less, or maybe because of the changing of the humidity rapidly, normally occurring, in the winter times, like the crack of the melon. And if this one happen, and basically, you're going to lose most of the melon, within that plant, if this kind of problem happen. So believe it or not, with the machines, you get more than 90% yields. I don't know what is the real problem that can cause from using the human. So I have to thank, the research funding, to research funding that giving for this project to make one of the IoT system and platform for this research. And that will be all for my presentation. I think I took most of your time here. So thank you so much. Please let me know if you have any question. Yes. Hello. Actually, I'm received something from the chat. Let me read it now. Okay. How we can deploy smart farming, cannot invest on the technology. Okay, the black given point. Okay. Too costly, but the internet. Okay. From the question from the, on the chat box, I could see that mainly about how the farmer can afford the system, or how can they maintain the system. Actually, the system that that we start working is actually, did not cost much, and because the first thing we did order in like a big amount of the pieces from the electronic device, and then also the sensors. So we order in the quantity at the beginning. So the total price is quite, is quite low comparing with the existing technology that they normally build, for like a big manufacturing, like almost, it only is like 10,000 baht, including everything. And then they can, it can last, more than 1 year because we use not, we don't really use like two shift sensors and electronic component. We actually got some support at the beginning. And right now we also receive some support from the government that we start spreading the equipment, to other farms. Actually, it become commercial now, for the system here, that can mix different fertilizers, and then they can reschedule to mix the fertilizer for like 3 months, 4 months, by using different formula from the seed recipe, and they can control, how to irrigate by using the condition from the sensors. The price is not high because of the optimization from the design that I told you at the beginning. Now, and then also the server, we did not charge the user when they use the IoT server. Also, we did not charge that one because we got the funding from for 2 years. But beyond that one, maybe we have to think about, we have to think of some business model. Maybe we need to get some support from the farmer, like 100 baht, per year, not like the price of the Netflix that they have to spend like 400 baht per month. If they can pay for a Netflix, maybe they can pay like per year, for the smart farming system that they can work, with now. But I can tell more that right now, like we have installed this one to like almost, from the north, the south, and then the western and the east of Thailand, more than 30 farms already that, setting up the system. So just one of the example that we implement the IoT system for the real melon farm here. I don't know if anyone have any other question. Yeah, to maintain it, we definitely need the money, and we have to think of some more business model, later on after the end of the funding. How the IoT in agriculture to its footprint? Can you explain more, about this question? What do you mean, specifically about the footprint? I think it depends on how you, what application and what function that you need to, you need about sensing. Yeah. Using the sensors, actually, there are many challenges, like I tell you, starting from selecting the sensors. But when applying the sensor, actually, I did try to apply, many sensor nodes within the farm, like at the beginning of the farm, at the beginning of the plant, the middle of the plant, and then at the end of the plant. And then we use the average value, from all the sensors in order to make a decision to control, if you have to feed the water when you have high temperature, you have low humidity, within the soil. But using too many sensors sometimes may cause some problem to your system, because sometimes when you use the average, imagine if you have two broken sensor, if you have only one good sensor within the farm, and the average value, you're going to rely more on those two broken sensors. Sometimes you don't even know. So it is quite difficult to tell, how many point of the sensor that you need. So if you want to do the precision farming, really do the precision farming, maybe you have to invest more on the sensor to have like a good quality sensor. In that case, you may, can depend on the information receiving from the sensors. But it's quite difficult to tell, how and what sensors and how you can make use of it. And, it's quite difficult. We need to study more on this one. Oh, thank you so much. Congratulations, Melon Farm. Actually, we planning, to take it for some other farm also. Thank you so much. Thank you. Yes.
Thank you so much, sir, for such nice and wonderful session. Over to Bhagiliki, madam.
Thank you. Does it affect the plant growth? Yes, definitely with the machine, but I don't know what is failing when using without the system. Maybe the labor, they are lazy, or maybe, there are many factors, but the proof that we can show now is that most of the plant that use the system will have like very less problem in terms of the quality and also the quantity.
Thank you, sir, for,
Yes.
for enlightening us with knowledge and interesting things and saying that irrigation system by using an IoT and what are the challenges is being solved in case of the plant diseases and the workload reduces was really very good, and the benefits by using different productive yields and the diagram which you have seen the plant cultivation took place was very neat and very clean. So like this, yeah, it has been going on in Thailand. We are not aware of this, but we felt very happy that you saw us by using different sensors and by different microcontrollers, how it took place by using IoT applications. So, sir, it was a wonderful session, and thank you once again on behalf of Silicon Institute of Technology, Bhubaneswar, and also I thanks to all the participants contributed to this FDP of the day 3. Thank you, sir.
Thank you so much. Thank you, everyone.
Welcome, sir.
Thank you, sir. Thank you.
I request all the participants that tomorrow by 9 a.m. all of you are requested to join the day 3 of FGP.
Day 4.
Day 4 of the FGP. So all of you take care and stay safe. So tomorrow morning by 9 a.m. all of you please join the day 4 session. Thank you.
I request Pritham, please shut down the Zoom window.